I'd like to welcome you again in the course and congratulate you on taking a step to learn how to interface your C++ code to QML. Before we do anything, I'd like to talk a little bit about the relationship between QML, C++, and Qt. Qt was originally written in C++, and we have been using the C++ API of Qt for many years. In the last few years, they came up with Qt Quick, which is a new technology to write user interfaces that really work well on mobile devices. And the Qt company, the company behind Qt today, is pushing for using this technology to write user interfaces. And one of the benefits of writing your user interfaces in Qt Quick is that they work well on mobile devices. I don't know if you have tried to run a Qt widgets application on a mobile device. It really is painful to look at. So Qt Quick is the way to go if you are writing user interfaces, and specifically if you are writing your user interfaces for mobile devices. Now, you use Qt Quick to write your user interfaces. Where does C++ come in? Well, C++ is used to do the heavy stuff. If you are doing some heavy processing in your Qt application, you are most probably going to do that in C++ and then pass the result back to Qt Quick to be displayed. The C++ API of Qt is very powerful. It contains many things that you can't even dream of in QML. Things like networking, threading, database handling, and many other things you can do in C++, but you cannot do in Qt Quick, and you're not even meant to do in Qt Quick, because Qt Quick responsibility is really to provide a cool user interface for your users to look at. When a user presses a button in Qt Quick to do some heavy stuff, for example, you are doing some kind of image processing or some other heavy operations, when a user presses the button, you are supposed to call C++, do the heavy operation in C++, and then pass the result back in Qt Quick. That's the design that the Qt company is pushing for, and that's really the way you should write your Qt applications today. Okay, Qt is the overall technology. It contains a C++ API. It also contains a Qt Quick API. Qt Quick itself contains the QML language that you use to write your user interfaces. It also contains a JavaScript engine that lets you write some JavaScript in your QML code to handle some interactivity. When a user presses on a button, you respond to that button click in the JavaScript signal handler in QML. Again, you are supposed to do the heavy stuff in C++ and do the cool looking UIs in Qt Quick. Now, this course is about interfacing between C++ and QML. What do we really mean by that? To try and explain this, I came up with a few scenarios where you could practically need to communicate between the two sides. Let's say you have a button in QML and you want to respond to that button by calling a C++ method. This is one way you could interface between C++ and QML. You can also do the reverse. When something happens on the C++ side, let's say a timer times out or something, you may need to call a JavaScript function. Although this is not the recommended way to do things, it is possible to do, and I am going to show you how you do that in a few upcoming lectures. You may also need to create your own completely custom C++ types and expose them for use in Qt Quick. We're going to see how you do that. You may also need to design for some QML-specific features for your own C++ types. Let's say you want to use your type like you use an animation in QML. Let's say number animation on some property. If you want to use that syntax for your own C++ types, you may also need to do that, and it is possible, and we're going to see how you do that in the course. So these are some of the ways you may need to interface between C++ and QML. This is not an exhaustive list. There are certainly other good examples of how you can communicate between C++ and Qt Quick, but this should be a good start to give you a concrete idea of what this course is all about. Now, I'd like to talk about what you need to know to be able to make the most out of this course. You should have some background with Qt C++. You should also know your way around Qt Quick and QML. And last but not least, you should have an open mind and be willing to learn the things that we talk about in the course. In terms of Qt C++, you don't really need to be a wizard, but you should know some basics about object-oriented programming. You should know things like classes and objects. You should know about constructors and destructors, signals and slots, and all the things you see here. We are going to be writing classes like this. You see, we have a class defined here, we have a constructor, we have a few fields inside, and we have a bunch of methods that are going to manipulate the fields here. If what you see here is really not foreign to you, you're most probably going to be okay with the course. In terms of QML, you should know about property bindings. You should know how to use the basic items in QML, things like rectangle, images, and text. You should have a basic understanding of Qt Quick controls. You should also know a bit about animations and keys attached property. If you have some doubts about the requirements here, please do check out my previous courses on Qt, C++, and QML. We talk about these things extensively. In terms of the tools, you need to have Qt and Qt Creator installed. You also need to have the latest version of the tools installed. At the time of recording this course, the latest version of Qt is this one here. But you should go to the Qt website and get yourself a fresh new copy of the latest version at the time when you watch this. Okay, here I also have a few tips on how to get the most out of the course. You should really try and follow up what I do in the demos. Everything is explained with concrete examples. This course is very practical. We are going to spend most of our time in the IDE showing you how to set up things and really giving you a feel of how you interface your Qt Quick code to C++. And if you get stuck, try to solve the problem yourself. You may search the error on Google, whatever helps you to get the problem solved. If you still can't solve it, you can ask in the QA section on the course platform, and I am going to do my best to help you out. We also have a Facebook group and a Facebook page for the courses on Qt that we do. So these are the channels that we try to avail to help you out. Do choose what works for you and use it at your own convenience. Okay, this is all for the introduction. In the next lecture, we're going to dive in and show you how you can call a C++ method from Qt Quick. I'll see you in the next lecture. In this lecture, we're going to call a C++ function from QML using context properties. Before we do anything, I'd like to talk about the problem we're trying to solve here. We have a user interface in Qt Quick, and it is described here. We have a window, inside we have a column, it contains a button, and what we want to do is to call a C++ function or method when somebody clicks on the button here. This is our goal, and this is what we have on the Qt Quick side. On the C++ side, we have a class. You see that it is a regular C++ class. It is inheriting QObject, and we have our QObject macro here. And it really is nothing special. We have a few methods, and we have a slot here. So what we want is to call any of these methods from QML. For that to happen, we need a way to make these two sides aware of each other. And to do that, Qt provides different mechanisms we can use to communicate between C++ and QML. But in this lecture, we're going to use context properties. Context properties are a way to make your C++ objects available in the QML context so that they can be used from your QML files. There are a few steps you need to follow to expose your class as a context property. First, you have to modify it to make it recognizable from the QML side. You have to create an instance of that class. You have to expose it using a special syntax that we're going to look at. And you have to call the class from QML. Let's look at how you can modify the class. First, you have to make sure it is inheriting QObject. You have to decorate your class with the QObject macro here. And most importantly, for your class to be callable from QML, you have to flag it with the QInvocable macro, just like we do here. You see the regular method here is callable from QML. The same is true for the regular method with return method here. Another way to make your class callable from QML is to expose it as a public slot from your custom class in C++. Okay, you have your class. It is decorated with the necessary macros to have your method callable. The next thing you have to do is to expose your class as a context property. Here we have an example main CPP file. The first thing you see here that is important is we are importing QML context. Down, we are declaring our own object of the CPP worker class that we declared in a previous slide. And we are saying engine root context set context property here. This is how you pass your class to be recognizable from QML. The first parameter here is the name you want to use to refer to the class in QML. And the second parameter is a reference to the class instance as you see here. So when you do this, the class is going to be available in QML under the name bWorker. And bWorker here can be really anything. You can call it whatever you want. So after you do these two steps, the last step is to call your method in QML, and it really is easy. The way you do that, you use the name that we declared in the previous slide, bWorker here, and you put a dot and put the name of the method that you want to call. Okay, I know this might not make sense yet. That's why we're going to go to Qt Creator and show you all this in action. Here we are in Qt Creator. We're going to create our new project. It's an application, a Qt Quick application. We choose the empty one here. We call it Context Property Demo. Save it in a location on our drive. Hit Next. Hit Next again. Choose the latest version of Qt you have installed. We choose our kit. I'm going to choose the desktop kit. And we finish. Let's run the application to see what we have. And it is an empty window here. The first thing we want to do is to create our C++ class. We come here to the project name, right click, add a new, we choose C++ here, we choose C++ class. We give it a name, it's going to be called CPP Worker. It's going to inherit QObject. Select QObject in this combo box here, and you're going to have QObject ticked on this checkbox here. Hit Next. And our class is going to be created. You see that it is inheriting QObject. We have our QObject macro, and all is fine for now. We are going to define the methods that we want to call from QML. The first one is going to be void. It's going to return nothing. It's going to be called regular method, and it's going to take nothing in. The second method is going to return a QString. We're going to call it regular method with return, because we want to play with the return value. It's going to take a string for the name and an integer for the age. This is what we want. Now we want these methods to be called from QML. We need to decorate them with the QInvocable macro, and you do it like this. We copy the macro again, put it on the second method, and we have it here. We also saw that you can make your method a slot, and it's going to be automatically callable from QML. So we're going to define a slot here. It's going to be void. It's going to say CPP slot, and it's going to take nothing in. We're going to implement these methods. The quickest way I know is to right-click on the method, select refactor here, and add definition in CPP Worker CPP. We repeat the same steps and do the same for the slot. And we're going to include QDebug in the CPP file. In the regular method, we're just going to put a debug statement to say that CPP is talking regular method called. The method with return is going to construct a string for us and return it. It's going to take the name parameter and concatenate that to the age that we turn into a string. You probably know all this. And in the slot, we're just going to put a debug statement saying that CPP slot was called. Now we have our class, and when we call these methods from QML, we're going to see these debug statements. The next thing we want to do is to go to the main file and do a few things. The first thing you need to do is to import or include QML context. This is your chief weapon here that is going to bring your C++ powers to QML. We also want to include our class. We're going to say CPP Worker. It should be recognizable from Qt Creator here. We're going to create an instance of it. We're going to call it worker. And now we need to expose it as a context property. How do you do that? You say engine root context, set context property, and you choose this method here. You see that it wants two things. It wants a string that is going to be used to call things on this object in QML. We called that bWorker. And we need to pass a reference to the object that we want to expose. We're going to say worker here. Now we have the plumbing in place. We can go to QML and do some calling on this method of CPP worker. I am going to jump over to my QML file, change the title here to say, I am going to import Qt Quick Controls and put in a piece of code that I had prepared. It is nothing special. It is a column with two UI components, a button and rectangle. I'm going to run this so that you see what it is. Okay, you see we have a button that says call C++ method. When we click on it, we're going to call a C++ method, and we have some text that we're going to use in a moment. What we want to do is to call our regular method when a user clicks on the button here. And we can do that already. We can say bWorker. And you see that it is recognizable because we exposed it from QML using this line here. It is available as bWorker, the name we specify here. Let's go back to QML and finish this. And you see that the methods are really available. You see the CPP slot we exposed as a slot method. You see the regular method, and you see the regular method with return. We're going to call regular method. Let's run the application. Ready? We're going to click on this button, and you see that it is saying this is C++ token regular method called. And if you go back to C++, you see that this is what we say when this method is called. Okay, just to show you that you can call the slot, we're going to call it. We're going to say bWorker again and call CPP slot. And what are we going to see? We're going to see this is C++ token, CPP slot called. Let's run the application. Click. You see regular method called and CPP slot called because we are calling these two methods when the user clicks on the button here. I really hope this shows you how easy it is to call C++ method from QML. Now we want to call the regular method with return and assign the returned value to this text inside the rectangle here. How do we do that? We say bWorker, say regular method with return. We need to pass in something. It's going to take a string as the name. Let's pass in John, and we're going to pass in the age. Let's say John is 25. Why not? Before we run the application, let's go back to C++ and see what we can expect. The regular method with return takes a QString and it takes an integer and it concatenates the two things together and returns one string of these two things. So if we pass John here and 25, it is going to say John, 25 years old. Let's go back to QML. We pass in John, 25. Let's run again. John, 25 years old. Okay, we are calling a C++ method from QML, and it is returning something, and we are displaying that return value in our UI component from QML. Okay, now that you know this, I'd like to go back to the main CPP file and visit the QML context class to let you know a little more about it. Okay, you should read more on this here if there are things you don't understand on this class. What it really does, it defines the context within a QML engine. Contexts allow data to be exposed to the QML components instantiated by the QML engine. Okay, so the data that you expose using the QML context is going to be available to any QML file that you use in your application. To prove this, I'm going to come back to my application and add a new QML file. I'm going to call it other. So I'm going to come back here to the resource file, add new. I'm going to choose Qt here. It's going to be a QML file, Qt Quick 2. This is fine. and I'm going to call it other. Okay, we have the file here. Now I can say component on completed. When this component is loaded, I'm going to call bworker and call cpp slot. Why not? Now I am going to come back to my main QML file and create another item here. So I'm going to say other. And I don't know if you know what is going to happen. If you have some basics about QML, you will. When I run this application, this other component is going to be instantiated. And when it is loaded successfully, this signal on completed is going to be fired. And we're going to call our slot here. So if we run this application, we should see the message we see when we call this slot here. So it's going to say this is C++ talking CPP slot called. Let's run the application. This proves our case. We are able to use the data that we exposed in our main function in any QML file that we have in our project here. And this is really how you call C++ method from QML in a nutshell. Okay, this is all for this lecture. In the next one, we're going to visit a QML item called connections that allows to connect signals from different components together. I'll see you in the next lecture. In this lecture, we're going to look at the connections QML element, an element that allows us to pass signals back and forth between QML elements in a rather flexible way. Here we have a mouse area. Inside we have a non-clicked signal handler, and inside we are doing something. A problem arises if we want to do more complex stuff. What if we want to respond on this signal handler in multiple places? The connections element allows us to do that. How do we do that? Here we have an example. We have the red rectangle here, which has a mouse area. It has an ID here. And inside we have a non-clicked signal handler. Inside we say that we clicked in the red rectangle. Down here we have two other rectangles, the green one and the blue one. And inside you see that we have a connections QML element. Inside you define the target, which is going to be the source of your signal. And you say the name of the signal that you are responding to in this connections element. And you see that we are able to respond to clicks on the mouse area inside the red rectangle in the green and blue rectangle here. If this is not making any sense, we're going to go to Qt Creator in a moment and play with this, and you are going to completely understand this. But the main idea is to be able to respond to one signal in multiple places. Of course, it has many other applications, and one of the other uses is being able to respond to signals coming from C++, which is what we're going to do exactly in the next lecture. But first, we need to understand the connections object. We're going to go to Qt Creator and play with that. Okay, here we are in Qt Creator. We're going to create our new project very quick. We call it Connections QML Demo. Save it in the usual location. Hit Next. Choose your Qt version. Choose your kit. And finish. We want to change the title here to say Connections QML. We want to put in a row component, which is going to contain our rectangles. We are going to put in the first rectangle. ID is going to be red rect. It's going to have a width of 100, a height of 100. The color is going to be red. Inside we want to have a mouse area. ID is going to be red. It is going to fill the parent. And when it is clicked, we want to console log. Let's finish this. We want to console log. This is going to do. So what we want to do is to define two other rectangles, but we are going to leave out the mouse area because we want to respond to the click on this red rectangle in these two other rectangles using the connections QML element. Let's copy the rectangle here and paste it 2 times. So 1, 2. We need to change a few things. We have duplicate IDs. We need to take care of this. I'm going to call this green rect. It's going to be green, and we don't need a mouse area, so we're going to take it out. This is going to be blue rect. It's going to be blue, and we don't need the mouse area in here. Let's run the application and see what it looks like. Okay, we have the red, green, and blue rectangles. So what we want to do is to respond to the click on the mouse area here in the 2 other rectangles. For that, we're going to use connections component. And as we saw in the slides, we need to specify the target, which is going to be the source of the signal. The signal we want to connect to is going to come from this mouse area, and its ID happens to be red rect mouse area ID. We're going to copy it and make it our target here. We want to respond when somebody clicks. So we're going to type our signal here and put curly braces and respond to the signal in here. We're going to copy this console log message here to save some time. Let's put a tab here. And we're going to say this Let's run the application. What we expect is that we click on the red rectangle and we're going to see 2 messages. One is going to be from the red rectangle itself, saying that we clicked in the red rectangle. The other is going to come from the green rectangle here, saying that the green rectangle is responding. Let's click, and you see that this is green rectangle responding. We are able to respond to clicks coming from the red rectangle from the green rectangle. We can copy the connections component and do the same in the blue rectangle. All we have to do is say that the message is coming from the blue rectangle here. Let's run. Click. See that green rectangle is responding, blue rectangle is responding. We messed up our console log messages. Let's correct this. This is blue rect responding. Let's run again. Click. This is blue rect responding. This is green rect responding. We are able to respond on a signal in different places, and this power is coming from the connections component that we are using here. This is the main usage of this component, and I am covering it here because we are going to use it in the next lecture, capturing signals coming from the C++ side in QML. Okay, this is all I had for this lecture. I hope you know how you can use the connections component to connect a signal from one component to several other components. In the next lecture, we're going to take this a little bit further and connect a C++ signal to a QML slot. I'll see you in the next lecture. In this lecture, we're going to use the connections QML component to capture a C++ signal and connect it to a QML slot. There are many uses for the connections QML component, and one of them is connecting to targets not defined in QML, and that's the case we are interested in this lecture. What we want to do is to define a C++ class, and the class is going to emit some signals. One of the signals is going to be called call QML, and the other is going to be called CPP timer. We want to connect to those signals. And the syntax you see here is no different from what we saw in the last lecture. We are using a connections QML element here. We are specifying the target, which is our CPP class that we are exposing using context properties. The signal we have in C++ can be captured in QML using this syntax here. We say on, capitalize the first name of the signal, and specify the rest of the name of the signal. You're going to see how this works in a demo that we are about to do. But the main idea is to capture the signal we send in C++ and use it in a QML slot, just like we are doing here. Let's head to Qt Creator and show you this in action. Here we are in Qt Creator. We're going to create our project as usual. It's going to be a Qt Quick application. We're going to call it Connections CPP Demo. We save it in the usual location, hit Next, choose your Qt version, choose your kit, and finish. We want to create our CPP class. We're going to call it CPP Signal Sender. We create it like this. We give it a name. It's going to inherit QObject. We go to the header file and we define our signal. Our signal is going to say call QML. It's going to take a parameter that is a string, and let's just call it parameter. Why not? We also want to specify a slot. We're going to use this slot to emit the signal to be captured in QML. So what we're going to do, we're going to put a button in QML. We are going to call this slot. When you click on the button, this slot is going to emit the signal, and we are going to capture the signal in QML. I know this is convoluted, but it is the easiest way I thought of showing you this in action. Bear with me, I'm going to explain it, and you are going to understand. Let's implement this slot. Right-click, refactor, add definition in CPP file. And here we are going to emit, call QML, the signal we just defined, and we are going to pass in a parameter that is a string. Let's just say information from C++. This is going to do. Now we have our class defined. We have our slot, we have our signal. We need to go to main QML and expose it as a context property. You already know how to do this. We're going to include QML context. And down here, we're going to include the class CPP signal sender. We're going to create an instance of that class. Let's call it sender. Why not? Down here, we're going to say engine root context, set context property. We're going to give it a name here, CPP signal sender, and we pass a reference to our sender here. Just like this class is going to be available for use in QML, and we're going to use this name here to access it. We can go to QML, change the title here. We're going to say connections. I want to include Qt Quick controls. Put a column down here. The column is going to contain a button and a text component down below. Let's call this mText, and the text is going to say default by default. The button is going to say, and when it is clicked, we're going to say CPP signal sender CPP slot. Okay, we are going to call the slot here that is going to emit this signal, and we want to capture this signal in QML using the connections component. Let's go back to QML. We're going to go to the top here, put in our connections component. The target is going to be our C++ class, which is called CPP signal sender. The signal we want to capture is on call QML. Let's go back to the class and confirm this on call QML. Yes, it is. We're going to respond in here. We're going to put a console log message saying that we caught the signal in QML, and we're going to capture the parameter that was sent by this signal and use it to set the text of this component here. That way we know that we indeed captured the parameter that came from the signal. So we're going to say mText text equals parameter, because that's the name of the parameter that the signal is sending here. Notice that this name is very important. Let's spell it correct. Parameter. Let's go back to the, okay, here there's no problem. And here we say parameter. Notice that the name of the parameter is very important here. If you mess it up, your parameter is not going to be passed over. We capture it using the explicit name that we set here. So you have to remember this. Okay, before we run the application, I want to go through the flow of how this is going to work. We're going to click on this button here. After we click it, we're going to call a C++ slot. It is going to be called here. In this slot, we are going to emit a signal that is going to be captured in QML back again. Okay, we have a connections component. We are saying that the signal we want to capture is going to come from the CPP signal sender, the class that we exposed in main using the context property mechanism. We capture the signal like this, and inside the signal handler, we put a console message saying what we have, and we use the parameter text to set the text of this text component here. It really is this easy. Let's run the application. We have our app here. We have the button. It is saying call C++ method, and the text of the text element is saying default, which is what we expect. When we click on this, you see that the text is saying information from C++, and look at the messages that we have here. We're saying this is QML, call QML signal count, and we know that we are coming here after we emit the signal in C++. I really hope this makes sense. The main things for you to understand here is that you can send a signal from C++ and capture it using the connections element and targeting the class that you exposed in your main function, just like this. Okay, I know this might be convoluted for some of you. That's why I am going to go back to the C++ side and emit a signal completely from C++ without QML intervening in the middle. The way I'm going to do that, I am going to create a timer object. It's going to be QTimer class. Bear with me, you're going to see what I am trying to achieve right now. I am going to create a private section, create a timer instance, and I'm going to create an integer, call it value, like this. And I am going to define another signal that I am going to emit. It is going to be called CPP timer, and it is going to pass a parameter that is a string, let's say value. I am going to fall over to the CPP file. I should initialize my timer. Give it a parent, and my value is going to start at 0. This is going to be fine. Now I want to connect to when this timer times out, and every time the timer times out, I am going to emit my signal. Bear with me, you're going to see this after I type this out. I am going to say connect. I am going to use the lambda function signal connection notation. It's going to be mtimer here, pound symbol, QTimer, timeout. And it's going to be a lambda function that is going to capture everything in the context. We pass in the parameter list and a pair of curly brackets like this. Put a semicolon here. In the body of the lambda function, we want to increase m value, increment it a little bit, and emit our signal. We're going to say emit CPP timer, and we're going to say qstring number and say m value. Okay, we are emitting the value in our timer like this, and we should start the timer, and we want to emit the signal every 1 second. Let's try this. Okay, what I am doing here, I am emitting this signal every 1 second. Okay, this is the use of the timer. It is a class that allows you to do things periodically. This time our period is going to be 1 second. and you connect to the timeout signal of it, and you emit the signal every time the timer times out. I hope this makes sense. Now that we have this feature built in here, we are fully capable of capturing this signal in QML. To make this obvious, I am going to put in a rectangle here. I am going to give it a width of 200, why not? A height of 200. It's going to have a color of red. Let's give it a radius of 20. Inside, we want to put a text component. The ID is going to be mrect text. The text is going to be 0 by default. It is going to be centered in the parent. The color of the text is going to be white. And we want to increase the font a little bit. So we're going to say font point size. Let's make it 30. Okay. We can run this actually and see how this looks. Okay, you see our big rectangle here. So what we want to do is to capture the signal that we send, the CPP timer signal with the parameter that is changing every second. Remember, we are emitting this signal every second, and we are increasing the value every time we fall inside this lambda function here. So we want to capture the value every time it changes and update that in the rectangle component that we just defined in here. And that way, our signal is going to be completely coming from C++. The only thing QML is going to do is to capture the signal, grab the data, and use the data to set the text inside this text component here. So let's get to work. We're going to capture the signal. We're going to say on CPP timer. And we're going to say mrect text equals value. Remember that the parameter is called value here. Let's run the application, and hopefully it is going to work. Okay, you see that our timer is counting, and the signal to trigger the change of the timer here is completely coming from C++. And I hope this makes it very clear that you can use the connections component to connect the signals coming from C++ to slots in QML and do some crazy things like having a timer running like this. This is all I had for this lecture. In the next one, we're going to see how you can use Q properties to have automatic updates in QML when things change in C++. I'll see you in the next lecture. In this lecture, we're going to see how to use Q property to propagate changes automatically between C++ and QML. So far, what we've been able to do to transfer data between C++ and QML is one, to be able to call a C++ method from QML, and two, to be able to capture a C++ signal in QML. In this lecture, we're going to make things flow more automatically. To put things in context, let's talk about the problem that we are trying to solve here. Let's say we have a movie class and it has two fields. One is the main character, which is a string, and the other is a title for the movie, which is a string also. We want to expose these pieces of data in our movie class to QML and make the changes flow automatically. So if we change the main character in C++, QML is going to know automatically, and if we happen to change the same data in QML, C++ is going to know automatically. Q properties allow you to build something like this. And all you have to do is wrap your fields in Q properties like this. And Q property is a mechanism that is used outside the scope of passing information between QML and C++. But in this course, we are only going to cover how Q properties apply to passing data back and forth between QML and C++. We're not going to go any further. If you are interested, you can search in the documentation and you're going to find tons and tons of information on how this works. So the way you do that, you specify Q property, you pass in the data type for your field, you pass in the name of your field, and you specify methods that you are going to use to manipulate this field. You provide a getter method that is flagged by the read string here, a setter method that is flagged by the right string here, and a notify method that is going to be the signal that you emit anytime something changes about the field here. And you see the setter and getter methods here, and you see the signals implemented here. And one other thing you should know, we are going to expose this class as a context property, and we are going to have things wired automatically for us. Okay, we just talked about the C++ side of things. How do things look on the QML side? Where on QML, things look pretty normal. There is no sign that you are really dealing with the C++ method. All you have to do is read the property. You see here we are reading the title, and down here we are reading the main character. This is how you access the properties. And whenever you do something like this, when you say text equals movie.title, the getter for the class is going to be called. And when you want to set the properties, it really is the same thing you've been doing in QML all along. For example, here we want to change the title of the movie. We say movie title equals the text that we are getting from the text field here. It really is very simple. All you have to do is do all the wiring on the C++ side, and you can use your fields in QML very flawlessly. Right now, we're going to go to Qt Creator and play with this. Okay, here we are in Qt Creator. We're going to create our project. It's a Qt Quick application, an empty one. We're going to call it Q Property Automatic Connect Demo. Save it in the usual location, hit next, choose your Qt version. We're going to choose our kit here and finish. We are going to create our movie class. It's a C++ class, and we are going to call it movie. How creative. It's going to inherit Q object, hit next and finish. We have our class here. So what we want to do is to define our first Q property macro here. So we're going to say Q property, and you see that Qt is going to autocomplete for you. Click here, and don't do anything yet. I want you to type the data type for the property that you want to put in here. It's going to be a Q string in my case. And hit tab. You see that it's going to move to the next piece of data. I am going to call this main character. And you see that the other fields are automatically updated for me. This is Qt Creator trying to help you out. You can click enter, and you're going to see that everything is going to be generated for you. I'm going to close the pane here so that you see the entire thing. I am going to define my other Q property. The data type is going to be Q string. The name is going to be title, which is going to be the title of my movie here. I am going to hit enter, and you see that the getter, the setter, and the signal for notifying are generated for me. The next thing we want to do is to generate all these methods. We need to generate the getter that is here, the setter that is here, the signal that is here, and do the same thing for the title field that we have here. You can do all this manually, but Qt Creator has a way to help you out. You right-click on the property like this, hit refactor, and click Generate Missing Q Property Members. And when you do that, the first thing I want you to see is that the data field is generated for you. But it is generated in a bad place. I am going to fix this in a minute. We also have the getter. We also have the setter, which is a public slot. This is okay. We also have a signal generated for us. Now I want to fix this class a little bit. I am going to put in a private section and move my field in the private section of my class. I am going to move the definition for these methods in the CPP file. The way I do that, Qt Creator is also going to help me out. I click on the method, refactor, move definition in CPP file, select this. Do the same thing for the setter method, refactor, move definition. I go back to the header file. There are a few things I still need to do. I don't like to put the setter method in the public slot. You can leave it here if you want, but I am going to move it back in the public section of the class, and things are going to be a little bit neater like this for me. Right now, we have the methods generated for the main character property. We want to do the same thing for the title here. Right-click property, generate missing Q property members. We are going to have everything generated for us. This time, the title field is generated in the private section. This is what we want. All we have to do now is move the definitions in the CPP file. Let's do that. And we need to move the setter for our title in the public section of the class. And by now, our class is really ready to communicate with QML. We should go to main and include QML context to be able to expose this to QML. We should include our movie class as well. We create an instance of the movie class. Let's call it movie. And we expose the instance as a context property. This is easy to do now. We say engine, root context, set context property. We call it movie. We are going to use movie to access properties of the movie in QML. And we pass the address of the movie object that we just created here. Now we can go to QML and consume the data that we have in C++. We change the title to say Q property demo. I want to put in a column component, set the spacing to something like 20, and put in two text elements in which we are going to read the main character and the title of the movie. This is going to say title ID for the ID. The text is going to be movie title. You see that the property is already available in QML. We also want to set up a few things. We want to make the font a little bit bigger. So we're going to say font point size. Let's make it 20. We want to give it a width of 500 and put it in the center of the parent. We are going to say anchors horizontal center. Horizontal center. This is going to be okay. I am going to put in another text component, but it is going to be for the main character. Main car ID, and here we're going to say main character to read the property inside QML. Now that I do this, I notice that I didn't set the title and the main character to our object. There are two ways I can do this. I can come to C++ and initialize these two data fields here. Let's do this actually. It is always a good idea to initialize your variables. So I am going to say m title and say movie title. And m main character. Just like this, we can read these pieces of data in QML. If we run the application, we are going to see the data that we just set in C++. Let's run the application and see what we get. Okay, you see that we get movie title, main character, the default values that we have in our initializer list in the movie class. We can go back to the main CPP file and actually change this. We're going to say movie, set title. Let's say Titanic. Everybody knows this movie. And say movie, set main character, and say Leonardo. If we run the application, we are going to see the new data set. The movie is going to say Titanic, and the actor or the main character is going to be Leonardo DiCaprio. Okay, we have this. To actually show you that our getters are being called in QML, let's go to movie CPP, include QDebug, and in the getter, we are going to say getting the title, QDebug, And we are going to do the same thing for the main character. And we are going to put the same debug messages when we set something. So we're going to say setting the main character here and setting the title here. And if we run the application, we should see the getter methods being called. Actually, the setter methods are also being called because we are setting them when we initialize the application. You see, we set title, set main character. The get methods are being called when QML reads this. And the QML engine is reading this for us. And that's why we see that the getter methods are being called here. I hope this makes sense. Okay, now I want to import Qt Quick controls because I am going to use a few buttons shortly. I am going to go down in this column component, and down below I am going to put in a row component, Control A, Control I to align. I have a text field that is saying nothing for now. It is going to be used to capture data from the user. And we have a button that says change title, and we are going to use this button to capture the text that is in this field here and use the text to change the title of the movie. So what we're going to basically say, we're going to say movie title equals title text field ID here, text. Okay, we assign that to the movie title. And this is going to call the setter for us. I want to do the same for the main character, so I am basically going to copy this row component. By the way, I am not explaining because this is self-explanatory if you took some course on Qt Quick. And if you are rusty on Qt Quick, you should check out one of my previous courses on Qt Quick. Okay, here I am going to say main character text field. Let's say main car. This is going to do. I am going to call this button 1 for the title, and the second one is going to be button 2, just to make them a little bit different. This is going to say change main character. And we're going to say movie main character equals, why not copy this? It's going to be a little bit faster. So what is going to happen? We are going to be able to change the title and the main character fields of the movie object from QML. Let's run the application. You see that we have our UI components. We have the title, we have the main character. Let's say I want to change the title of the movie to Frantic. If I change the title, you see that we are setting the title and the title changes here. We can also change the main character. Let's say Daniel, for example, and change the main character to Daniel. And you see that we are able to set things from QML. And if you look in the debug output here, you see that we are setting the main character and reading the main character again. So what is happening here? We are changing the main character, and in the movie CPP file, the setter for the main character is this one. We are changing it. We are emitting the signal for main character. And because the component here is bound to the movie title, this is a property binding here in action, it is going to re-evaluate again and update the value here. That's why we are seeing the getter method called here. I hope you can see that this is pretty powerful if you expose your data like this using Q properties. And this is really all you have to do to expose your data in QML like this. You define your data fields and you wrap them in Q properties and provide the setter, getter, and signal methods as we did in this lecture here. And one thing I want you to see that I kind of forgot to tell you is that if you forget to emit the signal when you change something in your C++ class, let's say, for example, we forget to emit the signal when we change the title. Let's run the application. Okay, let's change the title to Frantic again. You see that the properties that are bound to the title here are not being updated because we are not emitting this signal when we change something in the C++ class. So be careful to remember to emit the signals when you change properties that are bound to in QML. This is something very important to remember. Let's run the application again, change the title to Frantic again, and you see that the updates are propagating correctly right now. This is all for this lecture. In the next one, we're going to see how you can use context objects to propagate the same things from C++ to QML. I'll see you in the next lecture. In this lecture, we're going to see how you can use the context object API to expose the properties of your C++ object to QML. The context object API is pretty similar to what we've been doing with context properties. The only difference is that it allows you to expose a bunch of properties together in one go. We're going to go to Qt Creator and play with this. Here we are in Qt Creator. We're going to create our project as usual. It's a Qt Quick application. We call it Context Object Demo. Save it in a location on our drive. We choose the Qt version. We choose our kit and finish. The first thing we want to do is come to the main CPP file here, import QML context. You already know that. This is our chief weapon. And we want to create two strings that we want to expose to QML. One is going to be the last name, the other is going to be the first name. How creative. We're going to say QString last name. It's going to be do. QString first name. It's going to be John. And we're going to expose these to QML using the context properties. We are going to first expose with context properties, and then we're going to wrap all this together in a context object and expose all this in one go. It's pretty easy. So we're going to say engine root context set context. And even here you see that we have set context, but we're not going to use this just yet. We're going to wait in a minute. We're going to say m last name, and it's going to be, we use q variant from value and pass in the last name. We're going to do the same thing for the first name, engine root context set context property. We're going to say m first name. And just like this, these values are available in QML. Okay, to use these values in QML, we're going to have to put in a few components. First, we're going to change the title here to Context Object Demo, because that's what we're doing here. And we're going to put a rectangle component. Inside, we're going to put a text component. The ID is going to be mText. This is good. We're going to give it a value of m last name. You see that it is available in autocomplete. We want to make the text a little bigger, so we're going to say font, point size. Let's make it a 20. We're going to see how this looks. We want to give the rectangle a few properties. The ID is going to be mrect1. Let's give the text here a 1, 2, so that it is descriptive. The width of the rectangle is going to be the implicit width of the text component here plus some margin. So we're going to say mtext1 implicit width. Let's add 20. We're going to see how this looks. The height is going to be mtext1 implicit height plus 10. Let's change this to a plus 2. The color is going to be beige. I love beige. You probably know that already if you have watched one of my previous tutorials. And the border, we want a border. It's going to be yellow, green. Okay, let's run this and see how it looks. We should have a rectangle with the last name inside, and you see here we have a do inside. We should center this. I love my things to be centered, so we're going to say anchors center in parent here. Very easy to do in QML. This is better. We should do one also for the first name. We're going to copy this completely and change a few things. This is the beauty of QML. You can copy and paste and adapt in a minute. This should be mtext2 as well, and mrect2 here. And this is going to say first name. And we should have do John. We are only seeing John because these two rectangles are overlapping. We want to move the second one to the right of the first one. The way we do that, we use anchors. If you know a little bit about QML, you already know this. So we're going to say anchors left equals mrect1 right. Should be to the right of the first rectangle. And we're going to add the left margin so that we have some spaces between the two rectangles. So we're going to say anchors left margin. And we're going to make this a 5. Let's see how this looks. We should have do John. Okay, this is better. Now you see that you can expose the properties from C++ and use them in your QML files. This is nothing new because you learned all this in a previous lecture. Now we want to use the context object to expose these properties. So the way context objects work, you define a C++ class and you wrap all your properties that you want to expose to QML in that class. And what you expose to QML is the object of that class, and the properties of that class are going to be automatically available to QML. I know this is a mouthful, so we're going to do this and you're going to understand. The first thing we need to do is to create a C++ class. So we should create it, add new C++ class. We're going to call this property wrapper. It's going to inherit Q object. And we are going to expose our properties as Q properties. So we're going to say Q property here. You already know how to do this. This is going to be a Q string, and it's going to be last name. We are going to create another one for the first name, Q property. The type is going to be Q string, and it's going to be first name, all lowercase. I love lowercase when I expose my properties like this. I don't know your preference. You can put in whatever you like. Now what we want to do is to add a private section to the class, which is going to contain the fields for these Q properties. We're going to generate all the methods that are needed. You already know how to do this, but this is a good chance to practice. We have setter, getter, a signal, and a field here. For the first name, we're going to do the same thing. And here we are. The field is here. I want to move these methods in the CPP file. I'm going to refactor and move definition to the CPP file. I'm going to repeat the same steps for the remaining methods. Set first name, move to the CPP file. Set last name, move to the CPP file. What else do we have here? I want to move these public slots to be public functions. Again, this is a matter of preference. You can leave them there if you want. So now that we have the class, we can go back to the main CPP file, include it. Property wrapper. We can comment out our strings here. So I'm going to do a block comment. And I'm going to create a property wrapper object, call it wrapper. I'm going to comment this out again because we're not using context properties anymore. And I'm going to say engine root context set context object, and I'm going to pass in the address of the object here. You see that it wants a pointer, so we're going to give it the address of our object here. We're going to say pound symbol and prop wrapper. This will do. Now I want you to notice that the names we gave to our properties, we're going to use this name here to get the properties. So we go to QML and change M last name to last name, and change M first name to first name, because that's what we are using now. The names for the properties are coming from here again. Last name, first name, last name, first name. That's what we should use in QML to read the properties. Let's run the application and see that it behaves the same. And you see that we have nothing in here. Why is that? We didn't set the last name and the first name. One way to set them is to use the initializer list. We can come back to the class definition here, go back in the CPP file, and initialize M first name and M last name. So we're going to say M last name. We make this say last name, and M first name say first name, just like this. If we run, we're going to see last name and first name in QML, because these are the initializer values. To have some values inside, we want to actually set the values when we instantiate the object in main CPP. That's the way I like to do things. I think it's more explicit and easier to understand. You are free to do it however you want. I'm going to say prop wrapper here. Set last name, do. Prop wrapper, set first name, John. And if I run now, I should see do John. Okay, this is what we want. We are seeing our values in QML, and we are exposing the entire object. I want you to notice that in main CPP, we exposed the entire object of prop wrapper, and everything we had inside here exposed as a Q property is going to be directly available in QML. Last name, first name, we are directly using them without saying anything like a CPP class. The same thing we used to do with context properties. We don't need to do this right here because the properties are directly available in the context. Okay, you can use them directly in your QML as long as you have the object that contains them exposed in the main CPP file like this. Okay, now that you know this, how is this different from exposing your properties as context properties, the way we did before? For one, all your properties are exposed in one go. So you have one place where you can manage all your properties. The other thing is that you can have updates to these properties automatically propagated to QML. So let's say that in the CPP file of the class, you have some logic that updates the last name or the first name. The changes are going to be automatically propagated to QML, and you don't need to take any additional step. If you were using context properties to expose your properties, you would have to manually reset the context property to have the changes reflected in QML. To show this off, I am going to add a few things to our class here. I am going to import a timer, QTimer, And this is a class that allows you to do things periodically. You're going to see this in a moment if you don't know the class already. We're going to create a field in the class. The type is going to be QTimer. It's going to be a pointer. Let's call it mTimer. Follow the same naming convention here. Oh, we messed this up a little bit. Okay, we have the instance here. I also want to add an integer and call it mRandomNumber, because we are going to generate random numbers in a given range and then use those random numbers to give random names to the first name or the last name. You're going to see this in a moment. So we want to come to the CPP file and say mTimer. We want to initialize this. We're going to say new QTimer and give it a parent of this. We also want to initialize mRandomNumber to 0. This will do. I want to include two headers that are going to help us with generating random numbers. We are going to initialize the seed for the random numbers. So we should say srand. I am going to create a string list, and the list is going to contain a bunch of last names. Control A, Control I to align. Now what I want to do, I want to connect to the timeout signal of the timer and do something every time it times out. The way I do that, I say connect mTimer. I'm going to say $QTimer timeout. This is the signal I want to use. I am going to use the lambda function notation for the signal slot notation here, my parameter list and my body. And I'm going to put a semicolon to end my statement here. Every time the timer times out, I want to generate a random number, and I generate it like this. And I want to select the random name from the list here and assign that to the first name of my class here. So I'm going to say set first name, because these methods were automatically generated when I created the missing methods for the Q properties, if you remember. And I'm going to say list random number. It's going to be the list item at the index of random number. And if you look here, the random number we generate is going to be between 0 and list size -1. Okay, this is what we're going to have here. So we're basically going to span the entire list because this list starts to be indexed at 0. You probably know all this already. Okay, now that we have the body of the lambda function ready, we should say mTimer start. And we want to trigger the timer every 3 seconds. So we put in 3000 for 3 seconds. And we can try and run the application and see what we get. But before we do that, I want you to think about what you're going to see. So what we are doing, we are starting a timer that times out every 3 seconds. And when it times out, we generate a random number and we set the first name to be a random name inside this list here. So it may be Johansson, Kevin, Matheson, whatever. You're going to see this. Let's run the application. We have Do John, Do Kevin, Do Johansson. It is changing every 3 seconds. If you want to change it a little faster, you can make this 1 second. Why not? Let's run again. Okay, you see that it is changing. And I want to bring to your attention that all of this is happening from C++. What we basically have is a class that is automatically updating the first name here. And this is a good thing you get from exposing your data wrapped in an object like this. Okay, now that you have this, I think it's a good idea to go back to the documentation and try to visit the QML context class. We visit it again. You can type the class name here, and it's going to come up. If you go to more, it says context allow data to be exposed to the QML components instantiated by the QML engine. And if you go down here, they show you that you can expose your data as a context property. And down here, they also show you that you can expose as a context object. And they do exactly what we've been doing in this course. So I just want you to know that these are two ways you have now to expose your data to QML. And context objects can come in handy sometimes, but I find myself leaning towards context properties because that's better for me. But you're going to see what works for you as you work with these things for a long time. Okay, this is all I had for this lecture. In the next lecture, we're going to see how you can call a JavaScript function from C++. I'll see you in the next lecture. In this lecture, we're going to see how you can call a JavaScript QML function from C++. Now, I don't know why you would do this because the general flow of working with Qt Quick and C++ is to do the user interface in QML and do the heavy lifting in C++. But crazy things happen, and sometimes you may need to do this if you happen to have a feature or functionality that is only available in JavaScript QML and you want to use that in C++. If you happen to need that, this is how you do it. On the C++ side, you define two things. One is the return value that you expose as a Q variant type. There's also the parameter or parameters that you're going to pass to the JavaScript function. And then you say a Q meta object invoke method. You pass in the root object where that JavaScript function is defined in the QML tree. Don't worry if you don't understand this, you're going to see how we do it. You pass in the name of the JavaScript function, and then you pass in the return value and the parameter decorated with the necessary macros. The return value is going to be decorated with QReturnArg. The parameters are going to be decorated with QArg like this. This is what you do from the C++ side, and we're going to do a demo in a moment. Don't worry. On the Qt Quick side, all you have to do is define the function, and then you're going to call it. One thing you should note is that the JavaScript function we're going to call is going to be defined at the root level of the QML file that we are going to use. The root element is this window here in our QML example file here. And the JavaScript function is going to be defined right below here at the root level. Okay, now that you have this idea, we're going to go to Qt Creator and play with this. Here we are in Qt Creator. We're going to create our project. It's going to be an application, a Qt Quick application. We're going to call it call.js from CPP demo because that's what it is. We choose our Qt version, choose our kit, and finish. We are going to create a class that is going to wrap the methods that we're going to use to do our thing here. Add new C++ class. We're going to call it QML JS caller. It's going to inherit Q object. You know this already. Finish. In the class here, we want to define a method that we are going to trigger from QML. For that to happen, we need to decorate this with the QInvocable macro. We want to put in a private section that is going to contain our private stuff. We put in a method that is going to call JS. We call it call.js method. And it's going to take a string parameter as well. Let's call this param. And we want to put in a Q object pointer that is going to be our QML root object. This is the object representing the QML item containing our JavaScript function. We want to provide a setter for this field here. So let's create a setter member function for this. Let's look in the CPP file. We have our setter here. We want to implement the CPP method. Inside the CPP method, we want to do two things. One is to debug output a statement saying what we are doing here. And then we want to call the JS method, which is what we do here. Okay, this method is implemented here. Did we spell it correct? Let's bring this back a little bit and see if this is what we have. Let's copy and paste this to be sure. Okay, this is right. In CPP method, we call JS method here, and we pass in the parameter that we got from QML when we trigger this method. You're going to see how we use this in a moment. Now, how do we call JavaScript? The first thing we need to do is to define the return value and the parameter that we are going to pass in. We do declare two variant types like this, okay, the return value and the parameter is going to be a variant that we build from the parameter that we got from the parameter list of the method here. And we are going to say QMetaObject invoke method. We want to pass in the root object, which is going to be QML root object. We want to pass in the name of the JavaScript function. It's going to be QML JS function. This is the name. We want to put in the return value. We're going to decorate that QReturnArg. It's going to be QVariant. This is the type of the data. And next, we're going to pass in the variable that we defined on top here, returned value. We want to pass in the parameter. It's going to be QArg. It's going to be also QVariant. And it's going to wrap around the CPP parameter that we passed in here. I think this is enough. Okay, this is the syntax. All you have to do is remember it. Okay, after we do this, we put a debug statement saying what we just did and showing the returned value to be displayed here. And this is the return value that we get from QML. Remember, we call this JavaScript function to do something for us, and it's going to give us back a return value. We're going to capture that in this return value variable here and show that here. This is what we are doing. We are turning that into a string because it was a QVariant when we got that from QML. Now we have the CPP infrastructure in place. The next thing we need to do, we need to expose this class as a context property. You already know how to do this. We're going to say include QQML context. We're going to include the class QML.js color. We're going to create an instance of the class. And we are going to do something a little bit special here. Why is that? Because we need to set the root item only when the QML file here has been loaded. Notice that there is a possibility for this load method here to fail, and we know when it has failed when the root objects list here is empty. So what we're going to do, we're going to put a pair of curly braces here, return when something is wrong, when this is empty, and do an else block here. And inside here, we're going to say JS color, set root object, and say engine root objects, and pass in the first one. Okay, so we should say 0 like this, or you can even put a dot first. All these are going to work. Let's do this because it's more intuitive. And just like this, we can do our normal stuff and use our object here in QML. And I just noticed that I didn't expose anything to QML. So I need to do that. I'm going to say engine root context, set context property. We are going to call it QML.js color in the QML context. And we're going to pass in the address of JS color here. This is going to be fine. One thing you need to be sure about is that you have a root object here, because if you don't have it, you're going to have a crash because the QML engine is going to try and call stuff on the root object here, and you don't have the root object. So make sure this is here. Okay, now we can go back to QML, change the title here to say call. This will do. The first thing we need to do is to define the JavaScript function. Remember, we called it, but we haven't defined it yet. And the name of it is going to be this. So we should copy this so that we don't have any typos and say function. It should be at the root level. It's going to take a parameter. The parameter is going to say param And the function is really doing nothing special. It is putting something to the console for us to see in QML, and it is returning some text that we should show in C++ when this function returns. Now we should provide a way to have this method called from C++. And remember, we had a method that we can call from QML, which is called CPP method. What we're going to do is to include Qt Quick controls because we're going to need a button. Let's put a button down here. It's nothing special. The ID is going to be mbutton for my button. The text is going to say call QML function from CPP, C++, and when this is clicked, we want to say what is our thing called. It is called QML JS caller, so we should call that. We say QML JS caller, and it's going to be CPP method, and we're simply going to say QML colon. Okay, just like this. So let's see what we can expect. When we click this button, we're going to call the CPP method here. It's going to put the text here, and it's going to call a method that is called call.js method. The method is here. It's going to pass in the parameter, and it's going to call JavaScript for us. And when it's done, it's going to show us the returned value from JavaScript, and we're going to end here. Okay, let's run the application. Hopefully it's going to work, and you see that we haven't included the QDebug header. We should do that. Let's run again. Okay, we have our button here, and notice when we click it, it says this is C++ token. We are calling QML, and QML gets control. You see that it says QML is token, and it's going to return something in C++. And we have C++ token again, done calling QML JavaScript. The return value is this is QML over to you C++. And if you look in the QML file, this is what we are returning from JavaScript. And this proves that our function here is being called. This is the message that we show in here, QML token, and all the things here. And this is the parameter that was passed when we called JavaScript. And just like this, you can call JavaScript functions from C++. And this is the syntax that you use here. It's really easy. Once you know this, you can call any function that you want. And for now, you just have to make sure that the function is at the root level. In a future lecture, we're going to show you how you can do this for a function that is anywhere in your QML tree. But for now, we can only call at the root level. Okay, this is all for this lecture. I hope you know how you can call your JavaScript functions from C++. In the next lecture, we're going to revise what we just talked about in this chapter. I'll see you there. You might not believe it, but now you know enough to be dangerous in connecting C++ to QML. In this chapter, you learned quite a lot. We started by showing you how you can use context properties to expose your C++ data to QML. And all that revolves around the line here, engine root context, and you set the context property by passing in the address of your C++ object. We moved on to show you how you can use connections to connect one signal from one component to multiple components. We showed you how you can do the same, connecting a C++ signal to a QML slot using the connections component. And then we showed you how you can use the powerful QProperty mechanism to have your changes from C++ automatically propagated to QML and vice versa. We showed you how you can use setContextObject to expose your C++ data to QML in one go. And we closed the chapter by showing you how you can call JavaScript functions from C++. It really is easy. You just have to follow this syntax here. Again, I want to give you a word of warning. This is not something that is recommended to call JavaScript functions from C++, but sometimes you need to do that. If you need that, you have it, but you should strive to try and move the complex stuff in C++ and only pass the result in Qt Quick to be displayed or do whatever it is you want to do with the data. This is all for this chapter. In the next one, we're going to cover the data conversions between C++ and Qt. I'll see you in the next chapter. In this chapter, we're going to focus on how data is converted between the C++ side of Qt and the Qt side. We're going to start by looking at the basic data types of Qt and how they are translated to the QML side. We're going to look at string, date, and number data types and see some of the added features that QML adds to these data types on top of the standard JavaScript data types. We're also going to look at sequence data types, things like lists and vectors, and see how they are mapped on the QML side. We're going to wrap up the chapter by looking at variant list and variant maps and how they are used on the Qt side. In the next lecture, we're going to look at the Qt basic data types. I'll see you there. In this lecture, we're going to look at how the basic Qt data types are mapped on the Qt side. You need to know about this if you are going to do any kind of interaction between Qt C++ and Qt. In most cases, you're going to have your Qt C++ basic types automatically converted to the basic types that are available in QML. The table here says more about that. The bool type on Qt C++ type is turned into a bool type on the QML side. Integers are turned into integers. And in most times on the Qt C++ side, if you take out the Q, you're going to be left with the data type on the QML type. So QString is turned into a string, QURL becomes URL. You get the idea. The same with colors, font, dates, and whatever you see here. Okay, now that you have this information, we're going to go to Qt Creator and play with us. Here we are in Qt Creator. We are going to create our project. It's going to be a Qt application. We're going to call it Conversion Basic Types Demo. Save it in a location on our drive. Choose our Qt version. Choose the kit we want. We choose the desktop one as usual and finish. The first thing we want to do is to add a class that is going to help us communicate between C++ and Qt. Select the project, tick Add New. It's a class we want. It's going to be called CPP class. We want to inherit QObject. Hit Next and Finish. Go to the header file. To simulate the exchange of data between C++ and Qt, we are going to emit a bunch of signals with parameters, and we are going to catch these parameters on the Qt side. So let's define a signal that is going to send an integer. It's going to be void send int, and it's going to have an int parameter. And we're going to put in a slot that is going to trigger the emission of this signal. We're going to call this slot from Qt. So we should say void cpp slot, just like this, and implement it in the cpp file. And what we want to do in here is emit send int, and we want to put in some int value. Let's say 1, 2, 3. We need to have some kind of buttons or something that is going to trigger the call of this method. Let's go back to QML and cook that up. Let's change the title here to something more descriptive. We want to import Qt Quick controls because we need a button. And we're going to put a button control in here. ID is going to be mbutton as usual. The text is going to be Quick Me. How creative. And we are going to put an onClick signal handler. And in here, we are going to call the C++ class. The class object is going to be exposed as a context property, and we are going to expose that as CPP class. So we're going to say CPP slot here. And this will do. We don't need a semicolon here. Now we want to come back to main to finish our plumbing here. We include QML context. You probably know this already. We also want to include our CPP class and define an instance of CPP class here and call it CPP class. Now we want to expose our object here. We should say engine root context set context property. It's going to be CPP class, and we're going to pass in a reference to our CPP class object here. Now, if we run the application, notice that in QML, we are just going to see a button. When we click on the button, we are going to call the CPP slot. The slot is going to emit the signal, and the signal is intended to be received in Qt-Quick. Let's put a debug statement here to make sure that we are getting this method called. And we should say qdebug CPP slot called. This will do. Let's make the C lowercase. Run the application. Okay, if you click the button, we should see this message here, and we are. Now we want to connect to be able to receive the signal in Qt-Quick. There are many ways you can do this already, but we are going to use the connections component in Qt-Quick to capture signals coming from the C++ class that we exposed in main here. Let's go back to QML, put in a connections component. The target is going to be CPP class, and we are going to say on send ent. Remember that our signal is called send ent, so we say on, capitalize the first letter, and put in the signal name. This is how you capture it in Qt-Quick. Inside the signal handler here, we are going to put a console log statement saying that we received an integer in Qt-Quick from C++. We are going to say the parameter that we received, and we are going to use this type of operator to print out the type of the data that we received. Now, you have to be careful about this param here because the name of the parameter is coming from C++. It is right here, param. And this is what you should use to read the data back in Qt-Quick. Now, if we run the application, we are going to see the message here that CPP slot is called, but we should also see this console log message here. Let's run the application. Ready? Click. And you see that QML received integer 123, the type is number. All the numbers in Qt-Quick are represented by the number data type. And you see that what we just saw in the tables in the slide is applying here. We are sending an integer and we are receiving an integer in Qt-Quick. Okay, we should play with other data types as well. So we're going to send double, void send double param. We should say double param here to have some difference. And we should emit the signal in CPP slot. And we should say 123.45. This will do. We want to comment out the integer signal so that we are not confused. We should go back to QML and say on send double. We can copy this, put that in here, and say received double. It's going to be double param now, and double param. Let's run the application. If we click, we should receive double here. Its type is also going to be number. We're going to put in another signal that is going to send a bool, a real, and a float. We are going to go to the CPP file, comment out the double one, and put our signal emitted here. Actually, you can uncomment these things if it doesn't confuse you. On the Qt-Quick side, we should put in the signal handler. I'm going to just put it in here. I don't want to type all this. We captured the bool parameter, the real parameter, and the float parameter. Let's run the application. Click. Bool is true. The real is this one. and the float is this number here, and they are all numbers, real and float. Now that you have the idea, I am going to put a bunch of other signals that I want to emit. There is one for strings and URLs, one for colors and font, date, point, size, and rect. We are going to emit the signal for string URL. The string is this one, the URL is this one. We are going to capture that in QML. I am going to put in a signal handler like this, Control A, Control I to align. And if I run, I should see my string and URL console log messages here. So we haven't imported QURL in C++. We should do that. Let's import QURL. We should also import a bunch of other classes that we are going to need for these signals. You see, we need QColor, QDate, QPoint. We should include these. I am going to do this in a batch here. Let's run now. Okay, let's bring the application output pane up. Click to see our string is here, our URL is here. They are received. And you notice that the URL is an object now. It is recognized as an object in Qt-Quick. It's a JavaScript object. Now we want to send color and font. We go to the CPP file and do that. To be able to play with this color, I am going to go to main QML here and put a rectangle on top of the button. ID is going to be mrect. Width is going to be 200. Height is going to be 200. Color is going to be black by default. It's going to have a radius of 20 to make it have round borders. And the button should be below the rectangle here. So we should say encores tap mrect button. Okay, let's run to see what we have now. Okay, we have our rectangle here. We can now capture the signal in Qt-Quick and put in our console log statement, Control A, Control I to align. And we are going to say the color and the font that we receive. Let's run and see what we get. Okay, click the button. The color is this one and the font is this one. Okay, you see that the font is interpreted as a string and the color is interpreted as an object. Now, how do you read some data from this? For example, if we wanted to capture the red, green, and blue component of the color, how would we do that? We can close this, go down below here, and put a statement like this. And you see that you can call the components on the color by saying the name of the color parameter and saying .r, .g, .blue. You probably know this if you took some Qt-Quick course before. We can also do the same to access the properties of the font. For example, we can capture the family of the font and whether or not the font is bold. Let's run the application to show this in action. If we click on the button, we are going to send the signal and we are going to say the red component is this one, the green component is this one, the blue component is this one, the font is Times and it is bold. And if you look on C++, this is exactly what we sent here. Okay, the font is Times and it is bold. We can actually use these values on the QML side. For example, we can change the color of this rectangle to be the color that we sent from C++. The way you would do that, you would say mrect color equals color param, just like this. You can also change the font of the text of the button here. So you can say mbutton font equals font param, just like this. Let's run the application, and if we're lucky, we're going to see our changes. Let's click. You see that the color of the rectangle changes, and you see the font of the button changes to be a little bit bigger. This is how you can use the data that you send from C++. The next target of ours is going to be date. We're going to send a date from C++. We can go to the CPP file and actually send a date just like this. We are going to capture the date information on Qt Quick the usual way on send date signal handler. And we're going to say that we received a date. It's going to be date param. And we can extract some information in the date object that we received. Let's run the application to see this. Okay, the app is here. And if you click, you're going to see that we received a date. It's going to be displayed in my locale here. I am using a Chinese locale, but you can see the day information, the month, the year, the time, and you can see that this is an object. And we can extract the year, the month, the day of the week, and the day of the month. In C++, we specified a direct date like this, but you can also pass in the current date. The way you can do that, you can say emit send date qdate current date. You can do this. Let's run the application and see what we get. We bring the app up a little bit, and you see that this is the current date and the current time in here. The year is this one, the month is this one, and the day of the week is this one. You can see that all these things are indexed starting from 0. Right now we are in October, but you see 9 here. That's because it is indexed from 0. So the 10th month is going to be 9. We're going to go back to the header file and see our next target. It is going to be send point here. We are going to send a point from C++. We are going to send a point like this, point information, 1 point and 1 Q point F with decimal points. We are going to capture the point on Qt Quick side, just like this, Control A, Control I to align. We're going to say what we received, and we are going to extract some information, the X, Y coordinates for the points in here. Let's run the application, bring this up a little bit, click, and you're going to see point information, the points that we sent, and you see that they are objects. That's why we are able to extract information using the dot notation that you see here. Let's go and see our next target. The next target is going to be send size. We are actually going to do all this together to save some time. Now you have an idea of how this works. Let's go to the CPP file and send a size and a rectangle. The size is going to be this. We're also going to use QSizeF to send sizes with decimal points, and we're going to do the same with rectangles. A rectangle with decimal points and another one without decimal points. We're going to go to Qt Quick side and capture these things. Control A, Control I to align. We're going to capture the size here and output the data. The same thing for the rectangle, really, nothing special. Let's run the application. Click here, you see the rectangle, and you see the size information here. And I just went through all of this to give you concrete examples of how you can send data back and forth between Qt Quick and Qt C++. Now that we have been sending data from C++ to Qt Quick, what about sending data from Qt Quick to C++? We're going to define a few methods to play with this and just show you that it is also possible. I am going to define 2 methods that should be callable from Qt Quick, Control A, Control I to align, and I am going to implement them. You know all this already. And when we receive a point from Qt Quick, we say that we received a point. And we do the same when we receive a rect from QML. Now what is left is really calling these methods from Qt Quick and passing in the parameters that we should receive in here. Let's go back there. We're going to comment out the call to CPP slot here. We're going to say CPP class and receive point, and we should pass in a point. And the way to define a point, right now we're going to use the Qt global object, and the way you do that, you say Qt point, and you pass in the arguments for the X and Y coordinates for the point. Let's say 200 and 300, this will do. Let's run the application. Notice that the signals are not going to be emitted this time because we are commenting out this CPP slot that emits our signals. Right now, we are only interested in sending data from Qt to C++, and that's what we do when we click on this button here, and you see that we receive the point in C++ from QML. We should also try to receive rect, CPP class receive rect. Now we can pass in our rect like this and put in our parentheses like this to get rid of the error. Let's comment out the receive point method so that we are not confused by this. And we should be able to receive the rectangle we send in C++, and this is what we have here. And I hope this gives you a good example of how you can send the data back and forth between C++ and Qt in Qt, and the QML engine is doing all the transformations for us automatically. We don't need to do anything special. The QML engine is doing all the heavy lifting for us. Okay, I know this lecture was lengthy, but I wanted you to have a concrete example of how you can implement everything you see in the table here, passing the data back and forth between the two sides that we are interested in the course. This should be all for this lecture. In the next one, we're going to play with strings, dates, and numbers. I'll see you there. In this lecture, we're going to explore the string, date, and number data types in more detail. When passing data back and forth between Qt C++ and Qt Quick, the QDate and QDateTime objects are transformed automatically to the JavaScript date object. We are also going to look at how to work with string arguments in QML, an added feature to the JavaScript standard. Next, we are going to explore the localization methods that are available for date, time, and string, and look at a few formats you can use when you are displaying date and time information. On top of that, we're also going to look at how the number type can be localized. We have a lot to cover. Let's go to Qt Creator and do that. Here we are in Qt Creator. We're going to create our new project. It's a Qt Quick application, an empty one. We're going to call it Other Qt Types Demo. Save it in a location on our drive. Choose the Qt version we have installed. We choose our kit and finish. We change this to show our project. We want to add in a class that is going to allow the communication between C++ and Qt Quick. It's going to be a C++ class. It's going to be called CPP class. As usual, it's going to inherit QObject. And we go in the header file. We want to put in the signals that are going to be used to send data to Qt Quick and the slots that we are going to call from Qt Quick. Control A, Control I to align. We also want to include QDateTime and QTime because these data types are referenced here in our slots. We want to implement our slots in CPP file. Let's do that. And here we are. When CPP slot is called, we want to send the current time and the current date time to Qt Quick. And this is how we do it. When the time slot is called from Qt Quick, we show the time that we receive. We also show the date time we receive when date time slot is called here. Now we want to come back to main CPP, and you know what we're going to do. We're going to include QML context. We want to include CPP class. We want to create an instance of CPP class. This must be becoming second nature to you now. And we should expose this to Qt Quick as a context property. We're going to say engine, root context, set context property. It's going to be CPP class as usual. And we're going to pass in a reference to CPP class, the object we defined here. Let's go back to Qt Quick and say that we are working with string, date, and time. We want to import Qt Quick controls because we are going to use some buttons. Let's put in the button here. ID is going to be mbutton. The text is going to say click me. And when it's clicked, we're going to say CPP class CPP slot. Let's double check that the slot is named CPP slot. This is correct. So when we call CPP slot, we are going to emit these signals, send date time and send time. We should find a way to capture the data that we receive from these signals, and we are going to use connections as usual. So we come to the top here and say connections. The target is going to be CPP class. Let's put in our signal handlers. The first one is going to be on send date time. We are going to capture the date time parameter, and we are going to capture the full year, and we are going to transform that to a GMT string. Let's revise the application. We click the button. This slot is going to be called in C++. The slot is going to emit the signals, and we are going to capture the signal here. Let's run the application and click on our button. QDebug is not included. This is my favorite mistake. QDebug. Let's double check and run again. And let's go to QML and see what we should get in here. Bring the app up again and click on the button. And you see that we say that the slot was called, and we come in here, received date time, and we say the time that we received. This is the current date and time in here. And you see that we can retrieve the year from the date time object and the date transformed to a GMT string. This is how you can send date time information from C++ to Qt and capture it in a signal handler like this. Now we are going to add a signal handler for send time. This is not going to be anything special. It is exactly the same thing, Control-A, Control-I to align. And we are going to say that we received the time, and we say the time that we received. Let's run the application. Click on the button, receive time, and this is the time that we received from C++. Now that we are sending time from C++ to Qt, what about sending time information from Qt to C++? Well, we can do that by calling a few methods. We can actually comment this out and call the slots directly that we defined and pass in date and time information. Let's go back to QML, create a new date object. We're going to say var date equals new date. This is standard JavaScript code. And we're going to say CPP class time slot, pass in the date, run the application and see what we get. When we call the slot, we see the date information in here, okay? And this is interpreted as time. What if we call date time slot? Let's do that. And let's comment this out so that we are not confused. Run the application. We click the button. We are going to send date time information to C++, and we should get this here. This is the object that wraps around our date time information. And this is how you can send date time information back and forth between Qt C++ and Qt. Now that we have seen this, I'd like to show you how to work with string arguments in QML. We are going to go to the top here and define a string property. We're going to say property string. We call it mValue, and give it a value that we define here. It's going to say clicked %1 times, and say double is %2. And these percentages here are going to be placeholders for the actual data that we're going to pass in here. To show you this off, I am going to create an integer property. It's going to be called click count, because it's going to count the number of clicks we do on our button, and I want this initialized to 0. This is no problem. And if we go down, every time you click on the button, I want to increment the click count. I am going to do that like this. And I am going to change the text of the button to the M value string here and replacing the click count and the double of the click count. The way I do that, I am going to say M button text equals M value and say arg click count. Okay, this is how you replacing stuff, and say dot again and say arg click count multiplied by 2, just like this. And notice when I click on the button, let's run the application. Click the button, you see that the text changes and it is updating as I click. This is how you work with string arguments. This is an added feature by QML. I think this is not available in JavaScript standard. This is something Qt added. And we had it on the C++ side in the QString class. And I think it's a very good thing to have. It allows you to display data very easily by replacing it and things like that. So you should know this. Okay, this lecture is getting pretty long. We're going to stop here and continue with localization in the next one. In this lecture, we're going to pick up where the last one left off, and we're going to continue and see how you can localize date, string, and number information. We want to go to the root level of the window and go down in here, and we want to do something when this component is loaded. So we're going to say component on completed. And if you remember in the slides, we said that date and time information can be localized if you try to display that as a string. These are the methods we're going to look at and how you can use them. We are going to define a date object, and we want to play with the toLocalDateString method. This method contains date information, so if you try to read time information in here, you're most probably going to get some garbage information. You shouldn't do that. This only contains date information. One way you might use it is say print mdate toLocalDateString. And if you try to print this, you're going to get date information. Let's do that. You see that we get the current date. You can also use these methods by specifically putting in the locale that you want to see your date information in. So let's do that. We can say print mdate toLocalDateString. And if we wanted to see our information in German, for example, we could pass in a German locale. Let's run this to see what we get. You see, we have the information in German. If you speak the language, you can understand this. We can also, for example, specify the locale in French, put in FR here, and put in FR in capital letters. Let's run this. Lundi 15 octobre 2018. This is in French. On top of the locale, you can also specify the format you want to see your information in. Let's say I want to see my information in Chinese, and this is how I specify the format I want my information to be displayed in. Let's run this to see what we get. And you see that in Chinese, I get the year, the month, and the day, and they are separated by these characters that are put in here. You can play with this and put in whatever locale you want to play with. And if you want to know the format that you can pass in here, we can go back to the slides and see different ways we can show our information. So 1D is the day as a number, 2Ds are day as a number with a leading 0, and you can read this to see what you can get. 3Ms represent the name of the month, something like Jan to December. 4Ms are going to show you the name of the month, something like this, and this is what we have in our example. You can play with this to see what you get and combine this with different locales to play with this and get a feel of how it works. Again, I should remind you that this function only gives you date information. If you try to extract time information with it, you're going to get some garbage, and you really shouldn't do that. It is not supposed to be used to give you time information. The next method we want to look at is the toLocale string, which contains both date and time information. I am also going to give you a usage example of it. This is a good example how you can use it. You can also pass in the locale and specify the format you want to see your information in: the year, the month, the day, the hour, the minute, and the seconds. Let's run the application and see what we get. And here is our date time information. We also have a locale time string method, which only contains time. We're also going to see an example usage of it. It only contains time information also. If you try to read date information from this, you're going to get something unpredictable. So you shouldn't do that. Let's run the application and we should see the time in this format: hour, minute, second, separated by columns. This is what we have here. Okay, we also have another set of methods that are used to construct dates from the formats that we have here. For example, we have a date like this. If we want to turn this into a date object, we can use from locale date string to turn all this into a date object. So how could we do that? We can say var and say my date for the variable name and say something like this. Let's collapse this so that we see the entire thing. Okay, you see that we are calling the from locale date string. We are passing in the locale we want to interpret the data with. We pass in the date and we pass in the format. If we try to print this date, let's actually put in some text. Date is, let's put in my date. Let's run the application and see what we get. My date is, you see that we see the date. Okay, the time is garbage because we are only interested in date information because we are using from locale date string. Let's see if we try to read this in Chinese. How could we do that? We could copy this actually and put it in here and run the application. Let's see what we get. Okay, we get the data in Chinese. What did we get before? We also get the data in Chinese. Okay, the data is being displayed in Chinese here because this is my default locale. But if you want, you could use all these methods to specify how you want your date displayed. We can also try and say my date equals this to pass in the same method, but we want to pass in the month names, but we are trying to read this in English while the month name is in Chinese. Let's try and see what we get. We're going to print the same thing again, run the application. You see that it says date is invalid date because we are trying to read something in Chinese and we want to read it as English. The fix for this is to read it in the correct language. So we're going to put in Chinese. And if we run now, we should see a correct date. Okay, this is what we have here. We also have a from locale string method, Control-A, Control-I to align, that contains date and time information. And this is how you read the information. You pass in the format that your data is in, and you pass in the string pattern that you are using to read that. And we read this in English. If we run the application, we should have date and time information based on this. And this is what we have here. We have a from locale time string method, Control-A, Control-I to align. And it basically is the same thing. The only thing is that this only contains time information, and this is exactly what we are reading in here. Let's run the application. It's only going to have time, and the date is going to be garbage. What you should care about in here is only the time, because that's what this method gives you. 16, 23, 35, 16, 23, 35. This is what we have here. On top of this, we can also do localization operations on numbers. We're going to play with this also in Qt Creator. We put in a debug statement to say what we're going to do, read the number in a given locale, and print it out again. This is what we are doing here. We are setting the locale to German. We are defining a variable here, and we are trying to read the number in a given locale and print it out again. Let's run the application. This is really not so interesting, but when you need something like this is going to come in handy. I just want you to know what you have available when you are working with localization. You can also do something like this, Control A, Control I to align. Notice the difference. We have a dot in here and we don't have it in here. And this is going to be recognized in German. Let's run the application. And we're going to have the same output basically, but notice the format we read the data in is different. This is what we have, and this is what we have here. To show you what can go wrong if you get these formats wrong, let's put a dot in here and try to read this. Let's run the application. And it's going to show invalid format because this is not recognized in the language we specified in here. So you need to be careful with this. You need to be aware of the rules of the locale you are working in if you try to read data in that locale. So I am actually going to leave this in here so that you know. When you come back to the code, you can see that. I'm going to put in a dot and say wrong format for locale. This should be enough to remind you. We can also do some currency output, Control A, Control I to align. For example, we can specify the locale to be Chinese and say the number is this one and output this as a currency. This is how you use the method to locale currency string. You specify the locale and the symbol that you want to use. Let's run the application. We should see 123 yuan. 83, invalid format. This is not what we want. Let's comment this out. Run again. Did we print that? I don't think we did. Yes, currency is yuan 123. If you change this to US, it's going to be in US dollars. It's going to be the English US. Let's run again. And this should be it. I have seen that for this to work, the locale has to be installed on your machine. For example, if I try to do this in French, I am going to get something unpredictable. Let's run this. It's showing me euros, but there's a question mark here, meaning that the French is broken somehow because I don't have the French locale installed on my computer here. So you should try the locale that is installed on your computer, on your system. If you need some precision on the output of the numbers that you put out, you can also do that using the second parameter as f here and specifying the precision you want. For example, I can print this to be 4 digits after the decimal point. Let's print this. Let's see what we get. We should get 4 digits. And if we want, we could put in whatever we want in here for the number of digits. And I think this is really enough to give you an introduction to work with localization on your strings, dates, and numbers. In the next lecture, we're going to see how to work with sequence collection types. I'll see you there. In this lecture, we're going to see how to work with C++ sequence types in QML. This is actually very easy to understand and handle. There are many list and vector types in C++ that are represented by arrays in QML, and we have a list here, a list of integers, all these different lists, the vectors, the standard vectors, and all these things here are transformed to arrays when they get to QML. We're going to create a Qt Creator project and play with this. Okay, here we are in Qt Creator. We're going to create our project. It's a Qt Quick application as usual, an empty one. We're going to name it sequence to array demo. Save it in the usual location. Choose the Qt version that we have installed. And we're finished. We should create our CPP helper class. You already know what we are using in the course, CPP class here. It should inherit Q object. This is the plumbing we need to play with these concepts. We are going to include a vector class, QVector, and define a private section here and put in a vector of strings, just like this. We want to define a method called QML array to CPP that we are going to use to send a vector or an array from Qt Quick and receive it as a vector in C++. So we're going to say QVector, QString, and say vector. This will do. And we need to decorate this as QInvocable because we want to call it from Qt Quick. We also want to put in another method, which is also going to be QInvocable. It's going to return a vector of strings, and it's going to be called, this is going to do, we want to call this method from Qt Quick to retrieve data from C++ and display that on the Qt Quick side. We want to implement these methods. Let's go up and implement this. Okay, I noticed that we have a typo here. This should be QString. Let's go back to the header and correct that. And we need to implement this method. This method is going to simply return our mVector field. And this is going to loop over the vector that we get from Qt Quick and display it in C++ here. So we're going to say for each, you can use whatever loop construct you want. This works faster and better for me. So I'm going to say QString, string in the vector container. And I am going to debug string. If you don't have QDebug included, you should do that because it is needed for this to work. Now, before we do anything, we want to put some data in the vector here. So we can say mVector. There are many ways to put data in a vector. You can append data. You can do a pushback to put data to the end. We're going to append. Let's say 1 mVector append 2 mVector append 3, and let's put a 4 and stop. Okay, this will do. Let's go to main to play with these things. We're going to include our famous QQML context. QQML context. We include our CPP class. We create an instance of it. And we set that as a context property to be available in QML. We say engine, root context, set context property. We say CPP class, and we pass a reference to our object here, CPP class. Now we can head over to QML and do our stuff. Let's say sequence demo for the title here. We want to put a button in here, so we should say import Qt Quick controls. We put a button in here. ID is going to be mbutton1. Text is going to be sent to C++ because this is Qt Quick. And when it is clicked, we want to create an array of fruits like this, and we want to send it to C++ using CPP class. Let's go and check the method again. It is called QML array to CPP. Let's copy that, come back to QML and put it here. Put in our array like this. I think this is going to work. Let's try it. When we call this method here, we're going to fall in C++ here, and we are going to loop showing each fruit and this array here. Let's run and try this out. Click the button and you see our fruits here from apple to orange. This is working. We are able to send an array on the Qt side and receive that as a Q vector of strings. And you can try and replace Q vector with a standard vector or a Q list. It's going to work the same way. They are all transformed to an array at the Qt side. Okay, now that we can send from Qt to C++, it is time to read from C++ and send to Qt. We're going to do that in this second button of ours. So we're going to say button IDM button 2. Text is going to be and when it is clicked, we want to call the method to retrieve strings from C++. Let's come back here and say var the same thing really and say CPP class and call this method here. Just to test that it is working, we're going to output its length and we're going to say print Let's run the application and see what we get. We should have a 4 because we have put 4 elements in the vector on the C++ side. We click on the button here, we see a 4, so this is a good sign. But the 2 buttons are overlapping. We forgot to position the second button in a better way, so we should say anchors top equals m button 1 bottom. We want to put it to the bottom of the first button here, and we can now loop over this thing to output the data in Qt. And it is very easy to do in JavaScript. We can say R for each and put in function in here, put in the element that we want to print, and put in the body of the function like this, and console log element. Let's try this out, see if we are correct. Read, and you see 1, 2, 3, 4. This is working correctly. We are able to send collection data from C++ to Qt and in the other direction from Qt to C++. This is all for this lecture. In the next one, we're going to see how to work with Q-variant list and Q-variant map. I'll see you there. In this lecture, we're going to focus on Q-variant list and Q-variant map. When passing data back and forth between Qt++ and Qt, Q-variant list is turned into an array on the Qt side, and Q-variant map is turned into an object in Qt. We're going to go to Qt Creator and play with us. Okay, here we are in Qt Creator. We are going to create our project. It's a Qt project, an empty one. We call it variant list and variant map demo. Save it in the usual location. Hit next. Choose the Qt version you have installed. We choose the kit, the desktop one in our case, and finish. We want to put in our helper class. It's going to be called CPP class again. And it's going to inherit QObject. We go to the header. We want to include our classes of interest, QVariant list and QVariant map. We are going to put in our public methods, Control A, Control I to align. One is going to pass data from QML to CPP. We are going to pass a variant list and a variant map using QVariant list and QVariant map. You can select one of the classes and hit F1 to go and read the information about the class if you want. Okay, you can do the same for QVariant map here and open the documentation to see what the class is about. Okay, let's close the documentation. We also have another method to get variant list from CPP and get variant map from CPP, and they return these classes respectively. In the private section of the class, we want to put in an object pointer, which is called QML root object. And from one of the past lectures, you may recognize that we used this when we called a JavaScript function from C++. We are going to do that in this demo here, just to practice how to pass these data types by calling a JavaScript function. So we need to provide a setter for this thing. If you remember, it's going to be this one. We are also going to provide a public slot to trigger the call to JavaScript. Now we need to implement these things. Add definition in CPP, repeat the same steps. And do the same for the slot here. We want to include a few classes in the CPP file. We also want to initialize our QML root object to null pointer to have it initialized. When we get data from QML, the variant list is an array. Let's put that in here. It is sent from QML as an array, and this is sent from QML as an object. I want to put this here so that you remember. We can print the data very easily, just like this. Okay, we can print the list by looping in like this, and we can print the map just like this. This is standard C++ stuff. We simply loop in the collection of keys and grabbing the data in the map at a given key, just like this. And we turn that to a string because they are represented as Q variants when they come in here. We can also build ourselves a variant list and return it in the get variant list from CPP method. This is just to have something to play with. You see that we return a decimal number, a color, a string, and an integer like this, and we can return it. And we're going to be able to print all this information in Qt Quick. We can also get a variant map like this, Control A, Control I to align. We define it and we put in some data. And then trigger JS call, because our JavaScript method is going to take both a QVariant map and QVariant list. We're going to create the data to put in. We create a list and a map like this, and we pass all these two data sets in the call to invoke method. We pass in the root object that we want to use. We pass in the name of the function that we want to call from the Qt Quick side, and we pass in the arguments that we want to work with. Notice that we don't put in a return value like we did in one of the previous lectures, because we are not interested in the return value. We can leave it out like this. Now that we have the class, we should go back to the main CPP file and modify it to use our CPP class. We're going to include QQML context. We're going to include our class, standard stuff by now. We need to instantiate our object. And we need to come here and modify a little bit, because we need to be able to have the QML file here loaded successfully to be able to call the root object. If we don't have anything in the root objects, we're going to return -1. But if we have something, we're going to say CPP class set QML root object, and we say engine root objects first. Now we can go to QML and use our magic. We want to change the title to QVariant, include Qt Quick controls because we're going to need a few buttons, and define our JavaScript function on the root level. It's nothing special really. We just have to make sure the name here matches the name that we called here, and they do match. Array object func, array object func. We pass in an array because the first parameter is a Q variant list, and this is what we have here. Q variant list is turned into an array, and Q variant map is turned into an object on the Qt Quick side, and this is what we have here. And we loop through the array, printing each element, and we loop in the array of keys, and we print whatever it is that is stored in that key. This is how you do it. This is how you loop through an object in Qt Quick or JavaScript. We want to define the first button. It is nothing special really. It is a button that simply passes data to CPP. We are going to call the method pass from QML to CPP, which is what we defined here. If you go down inside it, follow symbol under cursor, you're going to see the method. It is simply going to print the list and the map. Let's run the application. And before we see it, you see that we are passing in the continents in here. So when we pass data to CPP, let's see what we have in here. They are calling CPP class, and it is not defined in here because we forgot to call set context property. I am glad Qt Creator reminded me. So we should say engine root context set context property. We should say CPP class here and pass in a reference to our CPP class that we defined in here. Let's run again. And by any luck, we're going to see our continents printed. Click here. Okay, you see a list item, Africa, and you see the map. It contains item John, Doe, and Earth, which is what we passed in here exactly. We passed in an array that should be transformed into a Q variant list and an object which should be turned into a Q variant map on the C++ side in here. We want to go back to QML and put in a second button that is below the first button, Control A, Control I to align. And it says get variant list from CPP, and that's exactly what it does. It reads data from the C++ object that we exposed. It stores that in data, and we loop over the array displaying items like this. So what we should see is this list here. Okay, we should see 1, 2, 3, color, Qt is great, and 10 here. Let's run the application and see what we get. On the Qt Quick side, let's move this over, call this. You see that we have 1, 2, 3, we have a color, we have Qt is great, we have 10. We can store different value types. We want to go back to QML, put in a new button that is going to read Q variant map data. That data is going to be stored as an object, and we loop over it as an object, printing each element in the object. You can recognize the same pattern from the reading we did here for the object. It really is the same thing. We are just reading variant map data that we return in here. Let's run the application. We should see movie data. Let's do this. You see that the movie is Game of Thrones, the name is Jon Snow, and things like this. It really is easy to do. You just need to remember the data types and how they map together from Qt Quick to C++ and vice versa. Now we want to practice a little more on calling a JavaScript method from C++ and combine that with passing QVariant list and QVariant map. The way we do that, we're going to go back to QML and put in button number 4 like this, Control A, Control I to align. The button is going to trigger JS call, and that's exactly what it does. If we go to CPP class, we see that this is a public slot method, so it should be callable from QML. And what the method does, follow symbol and the cursor, it creates a variant list which is an array on the Qt-Quick side. It creates a variant map, which is an object on the Qt-Quick side. And we call invoke method on QMeta object, passing in the parameters that we need. Remember that the QML root object has been set in the main CPP file after we load the QML file. Okay, what we expect when we run the application, let's go back to QML and try to explain. We are calling this method when we click on button number 4. The method is going to create our data types. It's going to call this method in JavaScript, and we are going to come back to QML and do what we do in here. We're going to print array to print object, and you already know all this, how it works. Let's run the application and see what we get. We call trigger JS call, and you see that printing array, we print the array, printing object, we print the object. And ladies and gentlemen, this is how you work with QVariant list and QVariant map to pass data back and forth between Qt-Quick and C++. This is all for this lecture. I hope you enjoyed it. In the next one, we're going to recap what we saw in this chapter. I'll see you there. In this lecture, we're going to review what we saw in this section. We started by looking at the basic data types and how they are mapped when you pass them back and forth between Qt-Quick and Qt-C++. We saw that the transformation of these data types is pretty seamless, and you really don't have to do anything. The QML engine takes care of doing the transformations for you. And you see that the data types really are the same. QColor becomes color, QString becomes string, bool becomes bool, and things like that. You get the idea. We also looked at specific uses of string, date, and number. We had a chance to look at the localization capabilities that these types offer. We also had a chance to see that QDate and QDateTime are represented by the JavaScript date object on the Qt-Quick side. We explored how to work with sequence collections, both from Qt-Quick and from C++. We saw that these sequence collections are represented by arrays on the Qt-Quick side. And we closed the chapter by looking at QVariant list and QVariant map and how they are mapped on the Qt-Quick side. QVariant list becomes an array, QVariant map becomes an object, and we saw how to loop over these objects and arrays in the demos that we did. I hope this section was informative to you. In the next chapter, we're going to do a demo application that tries to put together the knowledge you have learned so far. I'll see you in the next chapter. I'd like to welcome you in this new section. This section is going to be about practice. We're going to put in practice most of the things we've learned in the course so far. We're going to develop a REST API client. We're going to download the data from C++ and feed the data to QML to be displayed. This is the overview of what we're going to do. We're going to start by using the Q Network Access Manager API to download HTTP data from the internet. We're going to parse that data as JSON and figure out a way to feed the data to QML. We are going to refactor our C++ code to make it work better. You're going to see the reason why. And we're going to show you how to remove items dynamically from your data in C++. The API endpoint we are going to use is shown here. I am actually going to go there right now. Okay, here we are. It is an API that basically fetches jokes from the internet. You can specify the number of jokes you want, and in this case we want 7. For example, if I want 2 jokes, I'm going to send a request and I have 2 jokes here. If I want 5, I can put in a 5 and I am going to get the data. The most important thing for you to notice is to see the structure of the data. We basically get a JSON object. It has a field called type, and in this case it is success because we got the data successfully. It also has an array that is stored in the field that we're going to refer to as value, and inside we have a bunch of objects. Inside you see that we have an ID, we have the joke, and we have categories in these things here. We're going to parse this in JSON. Okay, you have an idea about the API we're going to use. This is what the app is basically going to look like. The user is going to have the ability to choose the number of jokes using this spin box here. They can increase the number, they can decrease the number, and they can hit fetch to download the jokes, and they're going to be displayed here. And they can add other jokes, and they're going to be added on the list here. The user is also going to have the ability to scroll through all this stuff. We also want to give the ability to remove the last joke. So if the user presses this button a couple of times, you should see item disappearing from the list view here. The app is easy in nature, but there are a few things that might put you off if you are rusty on C++. This is how we're going to parse the JSON data that we get. We are basically going to capture the data that is stored in our data buffer. We are going to create a JSON document that contains everything we got from the internet. We are going to create a JSON object out of that, and we are going to read the value, which contains our array of objects. We are going to loop through the array, capturing JSON objects inside, and we are going to read the joke field in the JSON object, and this is going to be the thing we're going to display in QML. And we are going to add this to our list that is keeping track of the jokes. After you have the data, you're going to need to display the data in QML. This is how you're going to do it. You should be familiar with this already from the first chapter of the course. Okay, this is what we have ahead in the chapter. I hope it's going to give you a chance to practice things we've learned and see how you can use all this knowledge to build something non-trivial. In the next lecture, we're going to start by downloading HTTP data from the internet on the C++ side of our application. I'll see you there. In this lecture, we are putting together a foundation to download our HTTP data from the internet. We are going to go to Qt Creator and do that. Here we are in Qt Creator. We're going to create our new project. It's a Qt Quick application. We're going to call it REST Client V1 Demo. Hit Next. Choose your version of Qt. We choose the kit we want to use here, and we finish. The first thing we want to do is to create a helper C++ class. We're going to do that. Add a new C++ class. It's going to be called app wrapper. It's going to inherit QObject, and we finish. Let's go to the header. Because we are downloading data from the internet, we're going to need a few networking classes. We're going to need QNetwork Access Manager, QNetwork Reply, and QNetwork Request. If you are rusty on this, you should take a basic course on Qt, and I happen to have one where we talk about this thing, so you should check that out if you are having problems understanding this. We want to create a private section for the class here. We are going to create objects for these classes. We're going to say QNetwork Access Manager. We're going to need the QNetwork Reply object in here. We're going to need the QByte array. And we're going to need the QString list to keep list of our jokes. So we're going to say mjokes here. We want to provide a public method that is going to be callable from QML that is going to download HTTP data. We're going to have it return nothing. It's going to be called fetch posts, and it's going to take an integer for the number of posts. We want this to be callable from QML, so we're going to decorate it with the QInvocable macro. We also want to do another one. It's going to be void. It's going to remove last item. We want to provide a getter for the jokes here, so we go to refactor, provide a getter member function, and we're going to have it here. This jokes method is going to have an implementation in the CPP file. We also want to implement our custom methods here. Let's do that. Refactor, implement in CPP, refactor, implement in CPP, and here we are. We are also going to need a few slots to deal with networking. You're going to see how we're going to use these in a moment. I want to make these private, so I'm going to say private slots and put my slots in here. The first one is going to be called every time we have something new to read from our network request. And the second one is going to be used when everything has finished downloading. We want to implement these slots. We're going to use them in a moment. Let's do that. And we want to come to the constructor here and initialize a few things. We want to initialize our net manager and net reply here. So we should do that in the initializer list. We want to do it like this. Net reply. The net reply is going to be null pointer. When we start here, we're going to put in some data later. And for data buffer, we want to say new qbyte array. This will do. Now we want to see how to fetch our posts. We're going to put in a constant string for the API endpoint. You remember it from the slides, it is this link here, but we need to put a dynamic string that specifies the number of posts that we want. And it's really easy to do. We're going to say plus here, we say qstring number, and we pass in the number we got from the parameter. Let's do number here, and this should be fine. We are going to create a QNetwork request object in here, so we should include it to the top here. Let's come back down here and say QNetwork request. We want to set the URL to the endpoint here. We're going to say request set URL and say API endpoint here. And we are going to send the request. How do we do that? We're going to say mnet reply equals mnet manager get, and we pass in the request that we just built to the top here. And this is how you send the request to fetch HTTP data from the internet. Now we want to connect the signals from this net reply to the slots that we defined in here. We're going to say connect. We want to connect this to the ready read slot that we have in here. So we're going to say this. And we want to connect mnet reply, QNetwork reply finished to our data read finished slot here. So we're going to say this, and this will do. And every time we have something new to read, we're going to land in here, and we're going to do something in a minute. Every time we finish reading the data for good, we're going to fall in here. And this is where we are going to parse the JSON that we get. We want to come in data read here. Data ready read is going to be very easy. We are actually going to append whatever we read from the network reply to the buffer. We're going to say data buffer append mnet reply read all. Okay, everything we read from the net reply is going to be stored in the buffer here. And we're going to append that. Every time we come in here, we're going to add something new to what we had before. I hope this makes sense. When we finish reading everything, the first thing we want to do is to check if there wasn't some kind of error. And the way you do that, you say if net reply error. You say that there was some kind of error. And if everything is okay, we do something else. If there's an error, we want to qdebug something. So we're going to include qdebug and come back down here, qdebug. And we get the error that we got by saying mnet reply error string. We put it out for the user to see. If we don't have an error, we're going to fall in here and we're going to keep doing our work. The first thing we want to do is to turn the data we have in the buffer into a JSON document that we can parse. We want to grab the value array, Control A, Control I to align, If we go back to the API link, we're going to see that we have a value array in the response that we get for our request here. This is what we are capturing in our code. And we do that by saying QJSON array. We say data, and we read the value field, and we turn that into an array. And you see, we don't have autocomplete. We must have forgotten to include these classes. This is a good time to do it. So we include QJSON document, QJSON array, and QJSON object. And if I come back here and delete this and do to array, you see that it is recognized now. Right now, what we have is an array of JSON objects. If we go back to our link, it is the list here of values that we have, this 0, 1, 2, 3. And what we are interested in is reading this joke here. That's what we're going to do in a moment. We're going to loop through this list and capture the joke data for every item in the list. Let's go back to Qt Creator and do that. So we're going to loop over this array. We're going to say for every iteration, we're going to create a JSON object for the item at the index I and turn that into an object. And we are going to capture the joke string. We're going to say QString. We're going to say object joke and turn that into a string by saying toString here. And by now we should have our joke data inside this string. We should output it for us to see. We're going to say qdebug and say joke. This is going to be enough. And by now we are able to get data from the internet. The remaining thing for us to test this is to find a way to trigger the call for this method here. The first thing we need to do is to expose this class as a context property. So we should go back to main. You already know how to do this. We're going to include the QML context. We're going to include app wrapper. We are going to create an instance of it. Let's call it wrapper. And we are going to expose this to QML. We're going to say engine root context. We call it wrapper, and we pass in the address of our wrapper object right here. We should go to QML, put in a button. We don't need anything fancy. We're going to say import Qt quick controls and put a button down here. And we should give a title here, by the way. Let's say REST client v1. This will do. The button is going to have an ID. The text is going to say fetch. And when it is clicked, we want to do something. We want to say wrapper fetch posts, and we want to fetch 5 posts. Why not? We forgot a colon in here. Let's build to see that we have no boo-boos. Compile output. The build is fine. Let's run. And if everything is okay, we should see our jokes in the application output in here when we hit this button here. Let's do that. And you see that we are saying a few things in here. Okay, this should be our data that we are getting from the internet. These are the jokes from the API that we used. We can go back in here and put in the number of items that we got from the internet. We can do that here. Let's say qdebug number of items. And we should say array size. This will do. Let's run again. This is going to prove to us that we are getting what we asked for. Remember, we are getting 5 jokes, and the number of jokes is 5. This is fine. And this is what we set out to do in this lecture. We are able to download the data from the internet using the API endpoint that we used here. The bulk of this application is really to be able to use Q Network Access Manager. You have to be able to create a request like this. You send the request and you keep an object to manage your request in net reply here. And we do everything in the slots that we connect to the signals of the net reply object here. One is data ready read, in which we append the data we get in our buffer. And the other one is the slot that says that we have finished our download and we can capture the data that we have in the buffer. And we do exactly that right here by creating a JSON document out of it. And we parse the data to get joke data right here. In the next lecture, we're going to figure out a way to feed this joke data to our QML file that we have in here and be able to scroll through joke data. I'll see you in the next lecture. In this lecture, we're going to figure out a way to feed the data that we get from the internet to the QML side of our application. And we're going to take a chance to actually build that side of QML. Let's go to Qt Creator and do that. Okay, here we are in Qt Creator. This is the project as we left it in the last lecture. The first thing I want to do is to actually build the user interface in QML here. The only thing we have now is just this button, but we also need a list view to be able to display the list of jokes. We also need another button to allow the user to remove the last item. And we need a spin box to let the user choose the number of jokes. Let's do that. We are going to use layouts, so let's import Qt Quick Layouts. Let's use 1.4. I think I have this installed. Yes, I do. And I'm going to put a column layout in here. It is going to fill the parent. And I am going to have a spacing of 0 because I don't want to have any space between items. I want to put in a list view. The ID is going to be mListView. Let's put in a model of 30 so that we have something to see before we put in some real data from the internet. I want to do an inline delegate like this. It's going to be a rectangle. I have some data prepared for the delegate data here, so I'm going to just put it in and try and explain it because it is not that difficult. The rectangle is going to have a width and a height. It's going to fill the parent in width. In height, it's going to have the height of the content in here, and the content is a text item. We have a color, a border, and a radius. Inside, we have a text component, which is going to display whatever data we have in the model. And in this case, it's going to display from 1 to 30. Okay, and we have a bunch of properties for this text item here. We have a width and height as well, the ID. We are centering it in the parent and things like that. We have a font, a wrap mode, and it is aligned in the center. Okay, let's double check. We have a model, we have a delegate. I don't think we need anything else to be able to see this list view. But before I run the application, I want to grab this button here and put it below our list view inside the column layout. We want to make the list view fill the available width and height in the layout. And we do that by coming below here. We can actually put this on top here, but I like to put it down, so you can put it wherever you want. We're going to say layout, fill height. It's going to be true. Layout, fill width. We're going to say true. And we want to do the same for the width of the button. We can run the application now and see what we have. We have a nice list view. You see we can scroll and see things from 0 to 29. It seems I was wrong. It is starting from 0. But the idea is the same. It is showing 30 items for you. Now we know that our list view is working. We can figure out a way to feed in the data from C++. How do we do that? For our data to be shown in QtQuick, we need to also expose the data as a context property. But the way things are organized now, we don't have a way to set a context property when we download the data. We don't have access to this engine here when we use our app wrapper. We could give this app wrapper a reference to the engine, but that would be very bad because we would be exposing too many things in main. What I like to do is to do the QML initialization in my class here, and that is going to have a side effect, which is a good one, to have the main function here very clean. If this doesn't make sense, bear with me. We're going to go back to our app wrapper. We're going to put in a public method that is called initialize. It's going to return a bool. We're going to call it initialize, and it's going to take nothing again. We're going to implement it, and we're going to basically take everything we have in here, comment it out, because we are going to port it in our class. I am actually going to copy all this because I'm going to need to replace these one by one. I am going to go in my initialize function. I will need an application engine. I should put this in the header file. Let's include this. And say QML application engine, M engine. This will do. We don't need to initialize this because this is on the stack. Now we should be able to uncomment this line and say M engine, root context, set context property. We want to pass the wrapper, but we don't have a reference to the wrapper here. The wrapper is actually this class that we are in, and we should pass in the this keyword in here. We are going to do the normal stuff we did in here, and we are going to return false when we don't find anything in the root objects. We want to actually wrap this in curly braces. This is what I like to do. And else return true when everything is all right. And you notice that I have forgotten to change these references to engine. This should be M engine. And you see that things are highlighted correct. Control A, Control I to align. And I am sorry if this is confusing you, but what we are doing, we are trying to do all the initialization we want to do in our class here. And this is going to give us access to the engine, and it's going to give us the ability to set context every time we want. You're going to see the benefit of this in a moment, but we need now to go to main and change to use this initialize method to initialize our stuff. We want to come back here. What we actually need to do is to say if not wrapper initialize. If we fail to initialize, we're going to return -1, and this is going to be fine. Okay, if we fail to initialize, we exit immediately, and if we don't fail, the application is going to keep on, and we are going to start the event loop here. Now we should get rid of this because we don't need it anymore. We also don't need context in here and application engine, but we should move the include for a QML context in our class in here. Let's try to put that in the CPP file and see if it works. Okay, before we run, I noticed that I didn't put a return keyword in here. So let's put it in. Return true when everything is all right. This is going to bring control back in here, and it's going to give control to the event loop right here. Let's run the application to see that everything is right, and it seems we are okay. Let's fetch to see what we get, and we get data from the internet. Now what we want to do is to do something when we finish reading the data. The first thing we should do is to append the data to our mjoke list here. So we should do that right here. Before we debug output, we should say mjokes append joke. After we loop in here, we should find a way to expose the data that we get as a model that we are going to use for our list view in QML. We are going to test to see if we actually had some data from the internet, and we're going to say if array size is different from 0, this will do. And we're going to say engine root context set context property. We're going to say my model, and we are going to expose a Q variant from the list of jokes that we have. We are going to say Q variant from value, and we pass in m jokes. This will do. And after we do that, we should clear the buffer so that further requests are not going to be disturbed by the data that we have in the buffer here. That's pretty easy to do. All you have to do is say mdata buffer clear. Now we should be able to come to QML and say the model for this list view is no longer a number like we had here, which can say my model. And you see that we recognize it here. Let's try and run. And you see that they say my model is not defined because it is only defined when we download the data in the slots to handle the download of data. But let's try to click and see what we get. And you see that we see the data. As soon as we download, my model is defined in our slot here. Okay, that's why we see the data when we click on the download button. Let's fetch again. You see that we are downloading some things from the internet. This is a good sign. We should go back to QML and put in a few other components. We want to put in a spin box and another button to remove the last item. Let's do that. The spin box is nothing fancy. Control A, Control I to align. We only are interested in the value that we are going to get from it. And we are going to pass that value in here instead of 5. So we are going to say spin box ID value to pass the value in the spin box. We also want to add another button. I am going to just copy this because I don't want to type all this. But we don't want to do what we do here. We just want to say remove last. And this is going to be M button 1. This is going to be M button 2, just to have them different a little bit. Let's run and see. Okay, we can now fetch 3 or 2 jokes, and you see we have 2 jokes. We can fetch another 3. This is working. We have 5 jokes. Now we want to go and get rid of this error here because we don't want to see it. Let's go back to the application and see what we can do. We are actually going to refactor this line of code here in its own method. Let's do refactor extract function. It's going to be called reset model. We want this to be private because we only want to call it in this class here. And you see that we have the method here, but Qt Creator seems to have messed up things. Let's Control Z to undo what we just did. And we are going to do the method ourselves. That's easier. Let's do void reset model. Let's implement the function in the CPP file. And we are going to copy this line here, say reset model, and put that in our refactored function here. And we want to reset the model when we initialize, because that's where we define the model that we can put in our list view in the QML file. We are going to say reset model. And if we run, you see that reset model was put in the last refactor that we did, so we don't want to put it in again. Let's build to see that we have no other errors. Seems we are fine. Let's run the application. And we don't have the error that we had. And we are still able to fetch data from the internet, 5 jokes. Let's fetch another 2. And we have them here. Now we want to remove the last post. We need to come back to our CPP file for the class and focus on remove last here. This is nothing fancy. We just want to check if there are elements in the jokes list, and we are going to remove the last item and reset the model to have the new data set exposed to QML. We are going to say if mjokes is empty, and we want to check that it is not empty, so we are going to put a negation here. And mjokes remove last. We have a method on the string list here, and we want to reset the model so that we have a new data set. Now we want to make sure this method is callable from QML. Let's see, remove last. Yes, it is. So what we can do is come back to QML, go to the button that removes last, and say wrapper, remove last, just like this. Let's run the application. We can fetch 5 posts so that we see everything. And when you remove last, you see that we are removing items. You can fetch 4 posts to have 5 posts in here. And you can keep fetching posts, adding to what you have in the list here, and you can scroll to see the entire thing. This is exactly what we want to do in this chapter, and you have outdone yourself by exposing your data from C++ and being able to display that in a list view like this. I hope you find this entertaining and exciting, and the bulk of this is really in this initialize method, where we set context properties exposing this class, the app wrapper class that we are using, and having this initialize method is giving us access to the engine right here in the class, and we are able to use it whenever we want to reset the model. This is very critical. For example, if we go in the remove last method and remove this call to reset model, let's see what happens. If we try to remove the last item, let's fetch 5 posts or 4 and say remove last. You see that the items are not being removed because the data in C++ is no longer in sync with the data that we have in QML. We are keeping them in sync by resetting the model like this. And what this method does really is to reset the context property by passing in the new data set from this list here. Whenever there is an update to the data we have in this mjokes string list, we want to reset the context property here so that the new model is exposed to QML. I hope this makes sense. So let's go back to the top here and make sure that reset model is being called. Let's run again. We want to fetch 4 posts. Remove last, and you see that our thing is working again. This is all we had to do in this chapter, really. In the next one, we're going to learn about new ways you can expose your data in QML so that you can even instantiate your items in QML. I'll see you in the next chapter. Okay, we are done with the version 1 of our API client, and I hope you enjoyed the process of building it, and most importantly, had a chance to practice what we have been doing in this course, exposing your data from C++ to QML. We have used the Q Network Access Manager API to download HTTP data in our application and parse that as a JSON object. You were able to feed the data to QML using context properties like you see here. And we had the chance to refactor our application so that the QML initialization happens inside our class. This gave us the ability to be able to reset the context properties as we see fit to provide update to the data in the model for our list views. And on top of everything, we also provided the ability for the users to remove junk data if they wish so. This is all for this chapter. In the next one, we're going to see different ways to register your own types to be used in QML and even be instantiated on demand. I'll see you in the next chapter.